Hello everyone. Great. Am I audible? Let me check once on my own. Hello, am I audible? Am I audible? Check once on my own. Hello, am I audible? Am I audible? Hi Thirumalesh, how are you? I hope everything is good. All are working well, doing your preparations. All the best for 2025 aspirants. The exam is coming very near now. Stop wasting any of the time. Keep studying. Yeah, I had this demand. This chapter of definite integrals is on demand. Some students were asking for definite integration, and that's why we have bought it today. So once again, hello to everybody. Vanakkam, namaste, namaskaram, and let's begin. Okay, without wasting any time. So indefinite integration, we have completed all the formats, all the types, all the methods, all the basics, standards, everything. Now you need to practice with more and more questions. Definite integration also plays a major role. This is a very important chapter. See, if I talk about mains or advanced, be it any of the two exams, both the exams, this particular chapter is very important. So stick tight to the chapter and let's study. Before that, one announcement, one information which all of you might be getting on your YouTube or WhatsApp or Telegram at another channels, but here also I would like to remind you that on 10th of this month, that means 10th of December, there is going to be an event, a very grand event, very important event for Unacademy. Now, what is the event? For that you have to find out on the day itself. You'll have to attend this particular event, and I recommend that if you have little amount of time also, please attempt this. For 2025 aspirants it might be difficult, but 2026 aspirants can definitely attend this event, and I would say there is a big surprise. There are so many big surprises during this event which you should know about if you are following Unacademy. Apart from that, one more announcement, one more big thing is going to happen on this channel. So now we know that for 2025 aspirants we could not do that much. We agree that yeah, for 2026 aspirants the time when this channel started was very less for 2025 aspirants, but for 2026 aspirants we have a lot of good and productive plans for all the 2026 aspirants. So that's why I would say that please go check the link which is in the description of this video, of this particular live stream also, and this video also. So one grand thing we are planning, one very good thing we are planning, and we have planned this on the other channels also, and on this channel also we are going to do it. Right, this thing is going to be very productive and helpful for all of you who are going to appear for JEE in 2026. For 2025 aspirants, right now we are, although we have done all our bit, almost every teacher, all of us have tried that as much as we can provide for 2025 aspirants, we have provided. We'll keep providing for 2025 aspirants also, but we have major plans, very productive plans for 2026 aspirants. So if you have not subscribed the channel, please subscribe it and ask your friends also to subscribe it. See, English is not a cup of tea for everybody. Not everybody understands English. So one advantage you already have is that you know English, you understand English, and you can speak English. And it's not just that because we were ruled by Britishers we should not like English. It's not like that. English is a connecting language which connects all over India. Indians speak more of English than even the Britishers. If you check the data now in UK, in United Kingdoms, the amount of land which Indians own is more than their own natives. So we are everywhere. English is going to be important. It's not like that because we understand more in Hindi or we understand better in our regional language, we should go for that only. If you understand English, this channel is for you. And for non-Hindi speaking students, this channel is going to be a very productive thing, a very important thing. Okay, so let's start. Okay, let's start with our session. Where is the remote thing? Let me check. Just a minute. Okay, Definite integration or definite integrals. See, if we talk about JEE perspective, be it mains or be it advanced, in both the exam, the percentage is from 4% to 10%. If you check 2023, the percentage of definite integration was very high. Yes, this chapter moves along with indefinite integration, but again, independently, if you do not know definite integration, if you don't know about the properties, if you don't know about the methods, this chapter is going to be difficult for you. So please try that. You can master this chapter. You can practice this chapter very well along with your indefinite integration, and it is going to be very helpful for you, very productive for you. Not much of things are there in this chapter, very few things are there. Basically, it's all about properties. Basically, it's all about properties. The major thing in this entire chapter is going to be your properties of definite integrals, which are going to help you a lot in solving very good questions. Now, the other things. Second fundamental theorem, geometrical interpretation, bounds of definite integral. This part can be sometimes really very helpful. Bounds. Sometimes if you are opting out if you are cancelling the options, if you want to cancel the options and solve your question of integrals very fast, then you can use bounds of definite integrals. Equations is another critical thing. Equations, although there is not much variety of question and involvement of Leibniz theorem and differentiation is more there in equations of definite integrals, but yeah, just like differential equations, this part, equations, is also critical, is considered critical in this chapter. So pay attention at this part also. Then in the end, an important helpful formula to solve a specific type of questions, which is Walli's formula, and on this formula also questions are asked in IIT. Now, main focus should be on properties. So if you have studied this chapter earlier, you must be knowing that without indefinite, we cannot do this chapter. If you have not completed your indefinite integration, indefinite integrals, standard integrals, formats and all, and the methods to solve integrals, then this chapter will sound and look difficult to you. If you are good or even average at indefinite integrals, then this chapter will be easily understandable for you. It's not going to be very difficult. But I must again tell you, this chapter is very important for JEE perspective. Now, let's come upon second fundamental theorem of calculus, right? Method for calculating definite integrals used to be very, complex earlier. It used to be very complex earlier, but because of some good mathematicians and some methods we introduced, and this particular thing became very easy. Indefinite means you're just finding the integration of a function. You are finding the integral of a function. That's indefinite. In indefinite integrals, we have a constant. When we write the integral of something, of a function, we write plus c. That means a constant is there. But in definite integral, there will be limits over here. That means it is definite. It is bounded. It is occupied by two values. This integral we are finding only between two values. That is why it is called definite integral. And the second fundamental theorem says that if your integral of f of x is, let's say, capital F of x, small f of x, integral is capital F of x, and if I am putting a and b, this is called lower limit, this is called upper limit, lower, upper. If I am putting f, a and b, then in simple terms, in simple words, I can just say this is nothing but f of b. That means integral of f of x is capital F of x. That means capital F of b minus capital F of a. That is going to be it. And now in definite integral, we don't have a constant. We don't need a constant, because even if we have the constant, that will get cancelled and will become 0. So there is no need for writing the constant. Indefinite integrals, find the integration of a function, and in that function, put these values. Upper limit, value of function at upper limit minus value of function at the lower limit. That's what you're supposed to do in simple terms. For example, same thing is written over here also. If f of x is a continuous function, first of all, in this interval, very important thing, it should be integrable. Integrable means it should be continuous. If it is continuous, then only it will be integrable, and if it is integrable between a and b, then only we can say that integral of f of x within a and b, that means lower limit and upper limit, is going to be f of b minus f of a. That's it. Okay, the f of b minus f of a. This is called the second fundamental theorem of calculus. This is what we are talking about. If we take a simple example, let's say x square dx, and we are calculating its integral from 0 to 1, then we know what is the integral of x square. It is going to be x cube by 3. And now what are we going to do? We are going to find the value of this. Well, this is our capital F of x. So what are we going to find? We are going to find 1 cube by 3 minus, here 0 minus 0. That means 1 by 3. So final answer will be 1 by 3. The definite integral of x square between 0 and 1 is going to be 1 by 3. That's going to be the value. That's how we are going to find it. That's how we are going to do it. Alright, let's move ahead. Now, here also there is a small catch. Here also there is a small catch that generally, what are we saying? Now this a and b which we are talking about, it's not closed interval. It is going to be under open interval. Right? It's going to be under open interval. So in generalized way, what do we say? We are finding the when we are doing f of b minus f of a. At f of b, value of function at b, we are not going to find the exact value of function at b. We are going to find the limiting value of function at b and left hand limit. Left hand limit at b and right hand limit at a. We can just say we cannot go above b. So we are going to say we are going to keep lower than b. So b minus left hand limit. And we cannot go down on a. We'll have to stay up from a only. So a plus. That's how we can say we cannot go above b. So b minus. We cannot go below a. So a plus. Okay. So limiting value of the integral of f of x at b. Left hand limiting value and right hand limiting value at a for f of x, where capital F of x is nothing but the integrand of our function. That's how we are going to find it. That's how we are going to do it. So this is called in general. This is going to be in general. All right. I hope till here things are clear. We have to grasp this. We have to understand this. This is what we are going to do. Now sometimes, most of the times this is going to work. Sometimes this will help because suppose at b your function is not defined only, then how will you find its value at b? Right? Suppose your function is 1 by x or something and it is not defined at b. So at b you are going to find its left hand limiting value, and at a you are going to find its right hand limiting value. If it is defined, if the function is defined at b and a also, then this is okay. This is okay. We can do this directly, not a problem, without any obstruction. But if it is not being defined at either b or a, then at b we'll be finding left hand limiting value and at a we'll be finding right hand limiting value of the integrand of the function. This should be very, very clear. First of all, before starting everything, this part is going to come useful at many points, at many phases in the chapter where the function is not even defined at b or a. Okay. Are we clear? This part, grasp it, understand it. Any problem? If I spoke too fast, then understand it. Even if you are watching the video later on, understand this part, write it down. If you are learning this chapter for the first time, this part is going to be important for you. Other parts obviously of the chapter are going to be more important. The parts as we move ahead in the chapter, everything is going to be important. There is nothing which is not important in any chapter. You know about IIT, you know about JEE, that they can ask you on the basic most of the facts of the chapter. It's not how much ever we teachers say that this is important, that is important, this is most important, that is not most important. It's not correct to say, because if we look at the past 5 to 6 year trends of JEE exam, they have asked question from linear inequalities, mathematical inductions also, which sometimes teachers, some of us even skip because we say that it's very easy. JEE is not going to ask questions from this part, but they do from the very basics of the portions also. So prepare every part. Equally important, pay attention at each and every part, especially for the students who are in class 11th right now, or the students who are going to appear 2025. pay attention at each and every part. You have to see out of 25 marks of math, you have to score at least 15-16, right, to get 99 percentile. That is a general assumption for 2025. So if you're targeting that, then you cannot miss anything. You never know from which part the question is asked, and if you did not complete that part, then easy question can also be missed. All right, let's do some questions to understand this. Now, for example, first question, right, A part. What are we finding? Definite integral between pi by 2 to pi of 1 plus cos 2x. Okay, 1 plus cos 2x. Now, 1 plus cos 2x, what is 1 plus cos 2x? We should be good with trigonometry to even start this question. If we don't know what is 1 plus cos 2x, how can we write 1 plus cos 2x? Any formula you directly know to integrate this? No, you don't know. So you have to convert it into single term, which is 2 cos square x, right? Which is going to be 2 cos square x. So this will become between pi by 2 to pi and square root of 2 cos square x. Now this dx, right? Now this root 2 is going to come out. And just like in indefinite, root 2 can be taken out. There is not major difference. Only this limiting, these limits are the bounds which we have to take care of. Otherwise, integration methods of integration are going to be same only, right? So now between pi by 2 to pi, root 2 came out. Square root of cos square x. Here we have to pay attention that whatever we are integrating, we have to keep in mind its value between this interval, pi by 2 to pi. Now we know root of cos square x is going to be cos x. Root of cos square x will be mod of cos x. Okay, pay attention, take care of that also. Root of cos square x will be mod of cos x, not only cos x. Mod of cos x it will be. Okay, so here we'll write mod of cos x dx. Now check between pi by 2 to pi, cos x is pi by 2 to pi, second quadrant. Cos x is negative, correct? So it is going to be square root 2 pi by 2 to pi and minus cos of x dx. Integral will be sin x, so it is going to become minus root 2 sin x, and we'll check it, we'll write its value between pi by 2 to pi. Now root 2 sin pi by 2 1, sin pi 1 and sin pi by 2 0. Did I say ulta kya? Sin pi 0, sin pi by 2 1. Okay, so I'll write over here. So minus root 2 into 0 minus 1 will again come out to be root 2 only. Final answer will be your root 2. That's how you calculate a definite integral. This is how you're supposed to do it. 0 minus 1 negative, correct. Okay, now let's move on to the next, ln x. Now if you have studied definite integration carefully, then you must have paid attention at the direct formula to write this down. Otherwise, you'll have to apply by parts first. So that's why we always recommend that you remember the basic integrals, right? Ln x is not a standard integral. We solve it with by parts. Yes, we have some students who have written the correct answer for it. Very good. Amazing. That's impressive. That's really impressive. That I'll write it over here. Integration of ln x dx is going to be x ln x minus x. This is something we should remember. Directly we should remember, it is going to help us out. Now here one more important thing is going to come up. Pay attention at that. Now this is, so we directly know the integral. There is no problem. X ln x minus x. We have to find it between 0 to 1. That's it. That's what we are supposed to do. Now, but ln x, is it defined at 0? At 1 there is no problem. 1 into ln 1 minus 1. 1 into 0 minus 1, right? Minus, when we'll put 1 over here, 1 into ln1, that means 0 minus 1. So this is going to just become minus 1. This is simply going to become minus 1. Minus, but ln x will not be defined at by Eilert principle. Yes, Eilert principle. Okay. Ln x is not going to be defined at 0. By parts you can apply over here. Yes, Eilert principle means by parts only, and by parts is this thing. By parts will give you this thing, but it is recommended that you remember the integration of ln x directly. Okay, it is going to come up at many places in questions sometimes, so it is recommended that you remember it. Now, ln x is not defined at 0. That's the problem. So what are we supposed to do? At upper limit, we'll find the left hand limit. At lower limit, at upper limit, this upper limit, we'll find the left hand limiting value. At lower limit, we'll find the right hand limiting value. So this is what we are going to do. Minus 1 minus limit x tending to 0 plus, right? This is what we are going to do. X ln x minus x. Now, limits should also be strong over here. As you move into class 12, all the concepts of class 11th as well as of 12th start combining together. So that's something which makes math trickier, in fact. Okay. This is not a problem. This we can say like this will become 0, x ln x minus x. This will become 0 directly. Not a problem. X ln x will become 0. Yes or no? Right? Minus 1, here we can write this limit x tending to 0 plus x ln x minus limit x tending to 0 x. This will become 0. Not a problem. This is minus 1. What will be this? What will be this thing? If you remember limits, then you'll remember that this is going to become just 0, right? This is just going to become 0. Limit x tending to 0 plus for x ln x. What do we do? This is 0 into infinity. Whenever we have 0 into infinity, what do? We make it infinity by infinity, right? So limit x tending to 0 plus, we'll write it like this. Ln x upon 1 by x. Okay, this is how we are going to write it. Then we'll apply L'Hopital rule. L'Hopital rule over here will make it limit x tending to 0 plus 1 by x upon minus 1 by x square, which will give us minus x, and again this will become 0. That's why this is said, this is also 0. This is also 0. So your final answer over here will be minus 1. Pay attention. Solving the definite integral is going to be very, very important. Sometimes these type of things will be helpful. If you have forgot the concepts of limit, revise them also. Okay. Basic formats and limits, right? That's what you need to know. Sometimes this is going to be the case. What did I say? When your function itself, here we could directly see, we know the integral. We know the integral. When we are putting the values at upper limit, there is no problem. This is becoming 0, minus 1. So minus 1. At lower limit, it is getting undefined. Ln x at 0. Ln 0 is undefined. So what are we supposed to do? When it is becoming undefined, there we'll find the right hand limit if it is the lower. Right hand limiting value if it is the lower limit of the integral. We'll find the left hand limiting value. If suppose 0 was over here, then we'll find the left hand limiting value for x ln x. Okay, this became 0, this became 0. So minus 1 is your final answer. Pay attention at these small things. Now this question. See, advanced in fact also asks from the very basics of the concepts. Try to look at the question. Try to see what we can do about it. Even advanced can ask your question from the very starting part. We have not begun, we have not moved very forward with definite integration yet. But yeah, this question is put here because to make you observe and make you note that from this part also questions can be made, and trickier for advanced question also can be made. Now what do we do over here? Now when you pay attention, you see that, sir, there is no problem. 1 by 2 and 0, putting 1 by 2 and 0 is not going to be a problem. Basically, problem which we are going to face is going to be to integrate. It's going to be in integration. Integration itself is going to bother us. Otherwise, this is not a problem. 1 plus root 3 we can simply take common out, but we have to integrate this thing. 1 plus root 3. Oh, sorry. We have to integrate this thing. Dx by x plus 1 whole square into 1 minus x to the power 6 to the whole power 1 by 4. Now, if you have studied your indefinite integration formats, all of them, you must remember that here linear into linear we have. So what we'll do, we'll create one linear below another. That's what we are supposed to do. That's what we do according to indefinite formats. We can either create this below this or this below that one, right? So how are we going to do this? How are we going to do this? Try doing this. Try it for a second. Just simply put 1 minus x below this, right? 1 minus x below this. So for example, let me do it a little bit for you. Instead of writing, we'll have to start from over here. So 1 plus root 3 is taken common out. 0 to 1 by 2, not a problem. Dx by 1 plus x to the power 2 into 1 minus x to the power 6, and to this whole power we have 1 by 4. Whenever such situation is there and there are big powers, but inside we have linear terms, we try to create one below the another. So here also we are going to do the same thing. 1 plus root 3 as it is this visible, right? This is, yes, this is in the screen, right? Okay, so 0 to 1 by 2. Okay, pay attention. First thing that we have to integrate it. Integration will put 1 minus x to the power 2 over here. So 1 plus x upon 1 minus x to the power 2. 1 minus x to the power 2 over here. When we are dividing over here, we'll multiply it over here also. When we'll multiply 1 minus x to the power 2 with 1 minus x to the power 6, we'll get 1 minus x to the power 8. Okay, to the whole power we have 1 by 4. That's what we have. Correct? This is how we are going to do. Now to the whole power 1 by 4, we'll bring it inside. Right, so 1 plus root 3, okay, 0 to 1 by 2, 1 by 4, so this will become 1 by 2, 1 plus, dx upon 1 plus x upon 1 minus x to the whole power 1 by 4 into 1 by 2, that means 1 by 2, this will become square root, and this will become 1 minus x whole square. 1 minus x whole square. What should be the next step? Can somebody tell me in the comments? What should be the next step? Next step, we know integrating this, differentiating this is going to give us this term. So this will put as t. This will put as t. Next step will be taking 1 plus x upon 1 minus x. We know, right? When we'll differentiate this thing, we'll get 1 minus x whole square in the denominator at least. Right? Numerator you don't worry about. Put t, correct. This we will take as t. This we are going to take as t. Okay. Now differentiate this. So what we'll have, dx, differentiation of this will be 1 minus x plus 1 plus x. Denominator will be 1 minus x whole square, u by v. So v square, u into v dash minus v into u dash. That's what we are doing. Okay. So 1 minus x plus minus will become plus over here. So this will become 1 minus x plus 1 plus x. 1 minus x into 1, 1 plus x into minus 1. And minus was here also. So minus I have written plus. That's why. So this is giving us 2 by 1 minus x whole square dx is equal to dt. Is equal to dt. Till here it is visible? Right? Dx is equal to dt. Now, next step. See, the question is not even of indefinite. Question is not even of definite integrals. We are actually using indefinite integration only over here. Correct? We are actually using indefinite integration only over here. Nothing else. That's what we are doing. So now this became like this. So now this thing will write over here 1 plus root 3. Now see, what have we done? When we are putting 1 plus x, 1 minus x equal to t. Now when we'll integrate, pay attention over here, one major step. When we are integrating, here we were integrating with respect to x. But here now we'll be integrating with respect to t. Why? Because dx by 1 minus x whole square. Dx by 1 minus x whole square will put this as dt. Correct? We'll put this as dt. And this will become root of t. This is t. So this part will be square root of t. Correct? So here we are going to have root of t plus 2. Now the limits. Because limits were for x. Now we'll have to put limits for t. How will we find the limits for t now? With respect to t, we'll have to put the limits. Getting my point? Here we had limits with respect to x because we were integrating with respect to x. Here we changed x. We substituted x with t. We substituted this with t, but eventually we are substituting x only, no? Correct? So now we are not integrating with respect to x. We are integrating with respect to t. dt is there. So our limits will also be with respect to t. When x is 0, what is going to be t? 1 minus 0, 1 plus 0. 1. When x is 1 by 2, what will be t? 1 minus 1 by 2, 1 by 2, 1 plus 1 by 2, 3 by 2. 3 by 2 upon 1 by 2, 3. So t will be 3. Correct? T will be 3. So our limits will also change if we are substituting. Remember this. Right? Although we are going to use it multiple times in the upcoming questions, but practice this over here itself. Now there is no problem. Correct? Actually, root t. Yeah, this we can. Any other substitution was also possible, kya? Acha, this will become linear only, no? So this will directly become 1 plus root 3 divided by 2 into 2 root t, and then we'll put the limits 1 and 3. That's how we can find it directly. This is not plus, this is going to be, this won't be plus, this is into 2. Why did we put plus? Root t into 2, no? Root t into 2. This 2 will come down. This 2 will come down. Okay. So these 2 will get cancelled, and finally we'll have 1 plus root 3 into root of t. We'll just put the values for 1 and 3. We'll check it 1 and 3. Okay. So let's check the answer if they have. Yeah, this thing only we are getting. Final answer will be 1 plus root 3 into root 3 minus 1. That is 2. That's what we are going to get. So indefinite should also be strong for you. Integral of 1 by root t is 2 root t. Integral of 1 by root t, 1 by 2 root t I have written. 1 by 2 root t. This 2 is also there, na? This 2 is also there. Okay. Let's come over here. Try to do this once. कौन है? Just a minute, sir. हाँ जी. X square. अच्छा. Here the only problem, the reason why this problem is here, that we are differentiating with respect to ln of x. We have seen dx, dy, dt, du, many things, d ln of x. I'm sure if you're solving thoroughly, then you must have seen this type of problem in differentiation or in integrals. This is common, but this is most common in definite integrals, because here the limits of integration, limits of definite integration, which will change with respect to ln of x. That's why this problem is over here. Okay, what do we have? We have 0 to 1 x square d ln of x, right? D ln of x. Just think about this. What is d ln of x? If you have solved this, then directly you'll catch what I'm trying to say. If you have not solved this, then understand it over here, right? So what is d ln of x? If we talk about d ln of x, this is nothing but 1 by x dx. How? What will be d ln of x by dx? This will be equal to 1 by x. If I put this dx over here, then d ln of x will be equal to 1 by x dx, nothing. Correct? So instead of this, we can just write this, right? D ln of x will be nothing but 1 by x dx. So instead of d ln of x, what are we going to write? We'll write x square into 1 by x dx. But will the limits change? Here we were integrating with respect to ln of x, but here we'll be integrating with respect to x. Now check, when your ln of x is equal to 0, in that case your x is equal to 1, and when your ln of x is equal to 1, in that case your x is equal to e. Correct? It will be equal to e. So now here 1x will cancel 1x, so but limits will change from 1 to e. When ln of x is equal to 0, x is equal to 1. When ln of x is equal to 1, x is equal to e. So change your limits with respect to what you are integrating, according to what you are integrating with respect to. Okay, so that's one change we need to take care of. So now what do we have? This will become, this is nothing but 1 to e x dx. So this will be x square by 2 1 to e, that means e square by 2 minus 1 by 2. That's what you will finally get. Major point over here, knowing d ln x, how to find if you have some function instead of x in dx, right? In that case, use this approach. Okay. Second thing, changing the limits according to what you are integrating with respect to. Okay. These two major things you have to take care of. Although this you must have understood, but no, you have not. We have not discussed this. But very important and simple remark is over here. While substituting, whatever you are substituting, right? Suppose for example over here, our function is some f of x, and in f of x we have 1 by x. In f of x we are substituting. There is some function which involves 1 by x, or the function itself is 1 by x. Suppose the function itself is 1 by x. In that case, we cannot substitute 1 by x as t. Directly we cannot substitute. Why? Because the interval of this function, the interval of this integration is from -1 to 1. And when we'll substitute 1 by x as some t, and we'll use dt over here, but then t is not defined at 0. This is not, t is not continuous. 1 by x is not continuous between -1 to 1. It is breaking at 0. 1 by 0 will be not defined. It is breaking at 0. So these kind of substitutions we cannot do. When we are substituting x with something else, or function of x with something else, then we should make sure that that something else is also defined in the same interval where we are integrating. Simple concept, simple to understand, but we have to take care of this. Sometimes this mistakes might happen. That's why this remark is there. Whose sound is this coming? Okay, now over here, by parts. As soon as you see the problem, two functions in product, by parts we have to apply. X sin x directly, we don't know we do not know its integral. So we know from starting itself, as soon as we see the problem, we'll know that by parts is going to be applied over here. Right? By parts is going to be applied over here. We'll have to use isolate. Okay, now you're okay with by parts and isolate also. X sin x, first function, let's say x, and second function, let's say sin x. But by parts itself, we can apply in two ways. In definite integration, we can apply by parts in two ways. One is that applying by parts on the complete thing. Okay, one is that we apply by parts, and on the final integral which we are getting, we'll apply fb minus fa. Okay, otherwise second way is that we apply the limits upper and lower in two parts. We have two parts in by parts, right? X into integral of first function into integral of second function minus integral of differential of first function into integral of second function. That's how we apply by parts. So let's apply first way, that x, this is, let's say this is my first function, this is my second function. So first function as it is into integral of second function, that means minus cos x. Correct? Minus integral of differential of first function, that means 1, into integral of second function, that means sin x integral, that means minus cos x, and dx. So this will become, here I can remove this minus and I can make a plus over here. Minus will come out and it will eventually become plus. So what do we have? Minus x cos x plus integral of cos x again will become sin x. Again will become sin x. And here I can apply 0 to pi by 2. So what are you going to have? Pi by 2, this will become 1, and at 0, this will become 0, this will become 0. So minus 0, that means equal to 1. This is one way. One more way of doing this is that we apply the limits at two different parts of our by part formula, by part line, and we'll apply by limits in two different parts. For example, here what we can do, we can apply x into integral of sin x dx. Correct? Here we can do 0 to pi by 2 and minus the second part, which is 1 into minus cos x dx, and here we can apply 0 to pi by 2. Now in definite integral, this is going to be sometimes more useful than the first method. This is going to be sometimes even more useful than the first method. Method 1 is okay. Method 1 you can apply, but sometimes you will not. Sometimes the need of the question will be to apply the second method. Not every time this will solve your problem. Sometimes this will solve your problem, because when we were doing indefinite integral, you must have paid attention that sometimes second part when we solve, it creates an integral which is similar, either similar to the main integral or it is negative of the main integral. In those cases, this will be helpful. Okay, in those cases, this part will be helpful. This method will be helpful. Correct? This is okay. If you're just finding the final value of the definite integral, this is okay. But suppose sometimes you have to prove something or find something related to the main integral. In that case, you'll have to use this. Okay, so this is going to become x into minus cos x 0 to pi by 2 plus, this will become sin x, plus minus minus, this will become sin x 0 to pi by 2. This is again giving you 0 minus 0. This will become pi by 2 cos pi by 2 0, 0, and at 0 this will become 0, 0 minus 0, plus this will become sin pi by 2 1 minus 0. That will again give you 1. Answer is same in both the cases, but both have their importance. This more than this one, this is going to be used in the questions of definite integral. We'll see some questions accordingly. But remember that sometimes if you're not getting the answer, that means you have to apply the second type or second method over there. Here is a question where you'll realize that what I'm trying to say. Okay, here is a question where you'll realize what I'm trying to say. Now see, 5050, okay, this thing is 50. Now 1 minus x to the power 50 to the whole power 100. Very big powers, question looks scary. What should we do? 1 minus x to the power 50 to the whole power 101. One thing is good, that this and this are very much similar. Suppose if I call this one as integral 1 and if I call this one as integral 2. Okay, both integral 1 and integral 2 are similar. Now we know that while integrating, we can create one integral from another. Either we can create I1 from I2 or we can create I2 from I1. We can do that. Okay, this feeling we already get when we read the question, when we see the question having big powers. One good relief is that they can be created. If they can be created, that means we have to apply by parts somehow. Whenever we can create one integral and second integral, either substitution here, there is no go of substitution. Here the catch will be with by parts. So we are going to try to apply by parts over here. Now how to apply by parts? We cannot apply by parts on both the things. On the complete integral we cannot apply by parts. It will be very much tricky, or it will become very complex. So we are going to apply by parts on one of them. Let's say we are applying by parts on I1. So I1 is 0 to 1. Okay, 0 to 1. 1 minus x to the power 50 to the whole power 101. Okay, this is I2. Okay, let's change this, no problem. Let's make this as I2 and let's make this as I1. Because if we have this, working with the denominator will be easier, right? Working with we have to get rid of the denominator. That is going to be more helpful for us. Basically, we have to find 5050 I2 by I1. So anything you can do, either you can solve I2 or you can solve I1. I wrote I1, so I made changes over here. Now I1, what is I1? Here we can apply the by parts theorem, right? We'll write it like this, multiplied with 1 dx. Okay, we'll write it like this. So what will this become? This will become 1 minus x to the power 50 to the whole power 101, right? Into x, first function into integral of second function, so into x minus. Now while integrating, also keep applying the limits. So here on this one, limits will be on this one, no? Into x, 0 to 1. Integral of second, that means integral of 1 will be x and limit over here will be from 0 to 1. Don't take this as mod. I'll use some other thing. I'll write it like this, 0 to 1. Okay, this is okay. Don't get confused by taking it as mod. Minus differential of first function, again 0 to 1 over here. Differential of first function, that means 101 into 1 minus x to the power 50 and chain rule. So 1 minus x to the power 50 minus 50 into x to the power 49. Minus 50. This will become your I1, let's say. Okay, minus 50 chain rule, minus 50 into x to the power of 49. This is what you are going to have. Into x again, 50 into x to the power 49 into x again, right? Why? Because differential of first into integral of second is 1. This whole thing with dx, right? This whole thing with dx. Now how is this going to help us? See, this is our I1. Okay, which is our I2. Acha, here it will become to the power 100. No? Here we'll have to the power 100. Here it will become 101 multiplied. 101 multiplied, power will become 100. So see, one thing is good that we are getting this thing over here. And 101 into minus 50 will make us 5050 only, which also we need already. Can you see that? Can you see why are we integrating? Why are we doing by parts and applying limits separately instead of applying the limits all together? Okay, so this is our catch over here. Now what your I1 will become, this thing, what will be this thing? 1 will give us 0 and 0 will also give us 0. This entire thing will become 0. Right? This entire thing will become 0. 1 will, at 1, this thing will become 0. At 0, this will become 0. So this is 0 only. This is going to be 0 only. Now, minus 101 into minus 50. So minus 5050. Minus 5050 into minus will be plus. 5050 will come out. Okay, 0 to 1. 1 minus x to the power 50 will remain. Okay, to the whole power 100 will remain. Okay, what else will remain? X to the power 49 into x. So x to the power 50 will remain. Correct what you were saying, no? X to the power 50 will remain. Correct. Now what should we do? Have we created I2 somewhere? Can we say I1 is 0 plus 5050 into I2 into x? No, we cannot say like that. We cannot say like that because this is not exactly what we are getting. We are not getting exactly this. Okay, 5050 into 1 minus x to the power 50. This thing we are getting. But there is x to the power 50 multiplied. What to do about it? We have to get rid of it. We have to get rid of it. How do we get rid of it? 1 minus x to the power 50 is there. Okay, what do we need? We need this to the power 100. We have I1. What was our I1? This thing. I1 was this thing. If we create 1 minus x to the power 50 only over here, then 1 minus x to the power 50 to the power 100 multiplied with 1 minus x to the power 50 to the power 1 will club and do something, right? Are you getting my point? We have to get rid of this. We have to get rid of this because either we should have got complete I2, we could say I1 is equal to I2 or the value is 1. But we have this x to the power 50 separately over here. We have to do something about it. What can we do? We'll club this. We'll do minus 1 plus 1 and we'll club this thing. We'll club this thing. Correct? That we can do. Right? We are multiplying this with this. Now see, I1 again. I1 is 5050 integration from 0 to 1. This thing will become 1 minus x to the power 50 to the power 100 into minus of 1 minus x to the power 50 to the power 101. So we'll have minus 1 minus x to the power 50 to the power 101 plus 5050 will get multiplied with this 1 also. Like 1 times 1 minus x to the power 50 to the power 100 will remain. No, this multiplied with this will give us this. Then this will be multiplied with 1 also. Correct? So 5050 0 to 1 1 minus x to the power 50 to the power 100. Now you see I2 is there. We have I2. We have I2. We have I1 also. We have I1 also, negative I1, but we have I1. Did you get my point? When we have to apply by parts and separately with the limits. So here we have I1 equal to 5050 into minus I1. This is minus I1. I1 is this. This is minus of I1. Minus will go out. Correct? Minus of I1 plus 5050 into I2. This is our I2. This is our I2. Exactly this. This is our I2. So you have to see when we have to break, how we have to break. So we'll have 5050 I1 equal to 5050 I2. No, wait. What do we need to find? 5050. Sorry. What are we supposed to find? Why are we getting confused? 5050 into I2 we have to find. 5050 I2 divided by I1. Yeah, so we have got the answer, right? We are getting 5051. This side will have 5051. Just a minute. Let me write again. Let me write this again. Arey, what is happening? Why are you taking text, bro? From here, let me write in white or green. I1 plus 5050 I1. So 5051 I1 is equal to 5050 I2. What are we supposed to find? 5050 I2 by I1. So 5050 I2 by I1, that means 5050 I2 by I1 will be nothing but 5051. That will be our answer. This is going to be our answer. Okay. So sometimes this manipulation will be very helpful, and you should remember that second approach of applying by parts and separating the limits in the two sections is going to be helpful in questions like this. I would recommend that you do this question once again. Now, what is written? Okay, yeah, this is what we are talking about, right? Suppose you are integrating between a to b. You are integrating a definite integral from a to b, but you know that between a to b, the function is discontinuous at some c, right? Suppose your function is discontinuous at some c and c is between a and b. C is between a and b. Then you can break your integral. Then you can break your limits in such a way that integrating from a to b, f of x is being integrated from a to b. Now you break it as a to c and then c to b. You can integrate separately by putting, because here c, a, c, c, b, these are open intervals. It is not defined at c, but when we are integrating, we are finding the limiting values. We are not including c and a. We are not including c and a. For c, we are finding left hand limit. For a, we are finding right hand limit. For b, we are finding left hand limit. For c, we are finding right hand limit. So we are not finding the value, or we are not integrating the function at c. Okay, we can break it in such a way. If it is not defined at c, then you can break your integration in, then you can break your definite integration in this way. There won't be any problem. Okay, so instead of writing this, you can write this directly. Won't be any problem. All right. Now some greatest integer functions. How to deal in definite integration with or when we have some greatest integer function inside definite integrals. It is going to be much easier than indefinite integral, because here we have a defined interval. Here we have a defined interval in which we are integrating. We know that greatest integer function of x, if you have the graph of, if you remember the graph of greatest integer function, it is like this. It breaks at integers. It is somewhat like this, correct? It breaks at integers. For example, let's say we are talking about first one. Do we have space? Let's say we are talking about first one. We are integrating from 0 to 2. Now x into greatest integer function of x. X into greatest integer function of x. We know between 0 to 2, this function is going to be discontinuous, or it will break at 1. There is only one integer between 0 and 2. Correct? 1 is the integer. It is going to break at 1. So what we will do, instead of writing x, greatest integer of x, we'll write it like this. We'll write from 0 to 1, x, greatest integer x, plus 1 to 2, x, dx, plus 1 to 2, x, greatest integer function x dx. This is how we're going to do. And now we know that between 0 to 1, not including 0, not including 1, between 0 to 1, everywhere the greatest integer of function of x, greatest integer function of x between 0 to 1 will be equal to 0. Any value between 0 to 1, the greatest integer of it will be 0 only. So this is nothing but 0 to 1 x into 0 dx plus this from 1 to 2. Between 1 to 2, the greatest integer function of x will give us 1, right? So x into 1 dx. This will become 0 only, plus this will become x square by 2. We'll find it between 1 to 2. So it will become 4 by 2 minus 1 by 2. 3 by 2 will be our answer. Okay. So it is dealing with greatest integer function in definite integral is easier. Try this. Try this for a while. I'll just be back in a minute. Please try this. I'm good, guys. How are you? I am good. I'm good. Keep up your preparations high. Take care of your health. This is going to be the winter season. Don't fall sick even for a day. Okay. During the JEE journey, I'm telling you, falling sick can be very risky sometimes. I've seen many students who have faced this. Okay, and they do regret it. Now, this question. Okay, anybody did this? Anybody who could solve it? Want to share the answer? Voice is correct, right? Not a problem. Let me check once. This is an important one. Okay, sometimes this basic or related to this basic most concept question is asked and we end up complexing this or complicating this, which is not recommended. This is very simple thing. See, we are integrating between 0 to 2. Greatest integer function of x square. Greatest integer function of x square basically. So, if we write like this, when x square is 0, what will be our x? X will be 0. When x square is 1, between 0 to 2, what all do we have? Right? When x square is 1, what will be our x? X will be equal to 1. When your x square is equal to 2, right? What will be your x? X will be equal to square root 2. When your x square is equal to 3, what will be your x? X will be equal to square root 3. And when your x square will be equal to 4, what will be your x? X will be equal to 2. Right? So we are integrating with respect to dx. So our x is between 0 to 2, not x square. X square is the function. Our x, we have to check for x. X is between 0 to 2. When x square is 0, x is also 0, x square is 1, x is 1. And likewise, when x square is 4, x is equal to 2. Right? Between 0 to 2, we are checking. So, as we know, 0 and 2, this is open interval. So, we are not going to need x is equal to 0 and we are not going to need x is equal to 4 also. X is equal to 2 also. We are not going to need it. Right? We don't need to break like this. We can start from 0. So, how will we break? We'll start from 0. We'll break in 0 to 1, 1 to root 2, 1 to root 2, then root 2 to root 3, root 2 to root 3 and then root 3 to 2. Root 3 to 2. We'll break it like this. Between 0 to 1, what will be x square? What will be greatest integer function of x square? 0 to 1. Greatest integer function will be 0 only. Plus, between 1 to root 2, 1 to 1.41. Greatest integer function of x square will be between 1 to root 2. Will be 1 only. Between root 2 to root 3, square, when x is between root 2 to root 3, root 2 to root 3, greatest integer function of x square will be again 1 only. Sorry, root 2 to root 3. So, root 2 to root 3, greatest integer function will become 2. Yes, square. Greatest integer function will become 2. Correct? Root 2 to root 3. Between root 3 to 2, root 3 to 2, greatest integer function, root 3 to 2, square, x square. When x is between root 3 to 2, greatest integer function of x square will become equal to 3. This will become equal to 3. So, this is what we are going to have. 0 plus 1 into 1 means x, right? X mean, like this is dx, this is also dx, this is also dx, and this is also dx only. So, dx, integration of 1 will be x in x, and then we'll put the values root 2 minus 1. So, it is going to be root 2 minus 1. plus 2x. So 2 into root 3 minus root 2 plus 3x. That means 3 into 2 minus root 3. This is going to give us our final answer. Let's check. Yeah, this only, right? 2 into root 3, 2 root 3 minus 2 root 2. Final answer is 5 minus root 3 minus root 2. This will be your final answer. That is how you are supposed to solve greatest integer function related questions. Okay. Now let's do this. Let's solve this. Root of x plus 2. Try solving this once on your own. If you remember one simple thing, that if we have a constant inside greatest integer function, if you have studied your functions very well, then you know that x plus k, greatest integer function of x plus k will be nothing but greatest integer function of x plus k. In addition, constant can come out. In addition, constant can come out. In multiplication and division, we cannot do this, but in addition or subtraction, we can do this. Correct? Remember, for any x, if x is any number, in the if k is any integer, if k is some integer, then you can take k out from greatest integer function. This you can do. Here k is an integer, here 2 is an integer. So here what we can do, we can write it like this. This will be nothing but 0 to 9 greatest integer of root x plus 0 to 9 2. dx is there by default. There is no problem in that. Okay. This will directly become this thing. This thing is directly becoming 2 into 9 minus 0. So 18. This is becoming 18. What about this? Now look at this. When your root x is 0, what is your x? X is also 0. When your root x is equal to 1, what is your x? X is equal to 1. When your root x is equal to 2, what is your x? X is equal to 4. And when your root x is equal to 3, your x is equal to 9. And you're integrating with respect to dx. Dx is between 0 to 9. So there is no problem. 0 to 9. Now you don't need to find. You don't need to put root x equal to 4. Right? When x is 0, root x is 0. Like that. This is how you are supposed to solve. So it will break in 4 intervals. Here also, we don't need this one and this one because we are integrating under open interval. Open interval. We are integrating under open interval. So these two we are not going to need. How will we break? 0 to 1. Greatest integer of root x dx plus 1 to 2, 1 to 4, 1 to 4 only we have written. Yeah, 1 to 4. 1 to 4. Greatest integer of root x dx plus then 4 to 9. 4 to 9 greatest integer of root x dx. What will this become? Between 0 to 1, root of x will be between 0 to 1 only, and greatest integer of it will give us 0. This will become 0 plus from 1 to 4, root of x. Root of x will remain between, root of x will be between 1 to 2. Correct? Root of x will remain between 1 to 2 when x is between 1 to 4. So greatest integer of function of root of x will be 1 only, 1 dx. Here 4 to 9. So root 9 is 3 and root 4 is 2. Between 2 to 3 it will be. So greatest integer function will become 2. Between 4 to 9, this will become 2 dx. Now the question is solved. This is 0 plus 4 minus 0 plus 2 into 9 minus 4 plus this. This is also remaining plus 18. So what do we have? 10 plus 4, 16, 16 plus 18. Let's check the answer. Yeah. No, some mistake we have done. Kya? 4. correct. Acha, 9, 10 plus 4, 14. 0 to 4. Oh, 1 to 4 it is. 1 to 4, 1 to 4. 1 to 4, so 4 minus 1. Okay, then also 3, 21 plus 10, 31. Yes, now we are getting 31. This is 31. That was the mistake. 31, correct. Okay. So, greatest Indian function, definite integral, regarding that, solve it very, very carefully. Solve it very, very carefully. Students who have solved, very good, great, amazing guys. Now, look at this question. One thing which we know, but I'm just reminding you again, differential inside integral cancels each other. Correct? Differential inside integral will cancel each other and the function will come out. Here also same situation. So differential is inside the integral. Okay. So what should come out? 1 by 1 plus e to the power 1 by x should come out. Basic instinct. K rule. K rule. K rule says no that differential inside integral, if we have, then the function will come out. They'll cancel or nullify each other. That we know. Will that be the case over here? Can we say? It could be the case if the limits were not minus 1 to 1. Why? Because between minus 1 to 1 there is a small beautiful number which is 0, and at 0 e to the power 1 by x is not going to be defined. So we cannot cancel differential and integral just like this. Here we cannot cancel differential and integral together and say the answer will be 1 by 1 plus e to the power 1 by x. No, we cannot do that. So what can we do? We can say that we'll break it. Obviously, if it is discontinuous at 0 and 0 comes in this interval, then we'll break it among or nearby 0 with respect to 0 only. So minus 1 to 0 will do, and we'll do 0 to 1. In minus 1 to 0, d by dx of 1 by 1 plus e to the power 1 by x, okay, plus minus 1 to 0, right, and 0 to 1, d by dx 1 by 1 plus e to the power 1 by x. This is how we'll have to break it. This is dx over here, this is also dx over here. Okay. Now what? Now we can cancel. Now there is no problem. But now there is no problem. Now we'll directly get over here 1 by, this will become 1 by 1 plus e to the power 1 by x, and we'll put the limits minus 1 to 0. We'll put the limits minus 1 to 0 plus, here we'll have 1 by 1 plus e to the power 1 by x, and here also we'll put the limits 0 to 1. 0 to 1. But again, there will be some problem. The question is not solved yet. Why? Because e to the power 1 by x is not defined at 0. Correct? Here also we have 0, here also we have 0. So what to do in that case? Obviously, this will be left hand limit. This will give us right hand limit. Here we'll have to find right hand limit. Here we'll have to find left hand limit. Break in the limits. So here we will break in the limits. What will this become? This will become limit x tending to 0 minus, here will tend 0 minus, right, 1 by 1 plus e to the power 1 by x minus, at minus 1 we are finding, so there no problem, 1 by at minus 1 it is defined, 1 plus e to the power minus 1 as it is we'll write, plus over here also 1 by 1 plus e to the power 1 by 1, no problem, 1 by 1, e to the power 1 by 1 will become e, but minus, here at 0 it is not defined, but this is at the lower end, so we'll put right hand limit, we'll put 0 plus limit x tending to 0 plus, so 1 by 1 plus e to the power 1 by x. Okay, Here this is the lower bound, so we'll put right hand limit. Here this is the upper bound, so we'll find left hand limit. At -1 there is no problem, at 1 also there is no problem. So this will expand like this. Now the thing is finding the limit. Now the major concern is finding the limit. Question is complete, but if we are stuck into limits, that in that case will not be able to solve it. Otherwise the question is definitely complete. So limit, we know this, limit of x when 0 positive we are finding, e to the power 1 by x will become e to the power infinity, that will give us infinity only. And when we'll be finding 0 x tending to 0 minus for e to the power 1 by x, why is it 0 minus will become, for e to the power 1 by x, 0 minus will become e to the power minus infinity, that means 0 only, right? E to the power minus infinity it will become, tending to 0 minus, so it will become e to the power minus infinity will be, which will be 0. This will be e to the power positive infinity will be, which will be infinity only. Correct? That is going to be the case. But sir, e to the power minus infinity, e to the power infinity, how are we going to put it? Limit or bound is coming as infinity. Is that okay? Is that normal? Is that not a problem? Not a problem. Why? Because here what we'll have? Here we'll have 0 minus. So 0, 1 by 1 plus 0, that will become 1 only. This will become 1. Minus e, the 1 plus 1 by e, so e upon 1 plus e, e upon 1 plus e, plus 1 upon 1 plus e, not a problem. What will this be? Where did the thing go? Limit x tending to 0 plus. 0 plus, at 0 plus 1 upon 1, e to the power 1 by x will become infinity. 1 by infinity will become 0. So this is going to be nothing but 0 only. So plus 0, that's it. Plus 0. Final answer will be 1 upon 1 plus e. Sorry, final answer I'll write over here. 1 minus e upon 1 plus e. This is going to be our final answer. That's it. So playing with limits should also be handy and you should be confident with that. In definite integral, there will be many scenarios where you'll have to actually use the concepts of limits. This one and continuity differentiability, there. Two places we have seen most of the usage or most of the application of limits. Acha, 1 is also there kya? So this will become 1 is also there. 1 plus this plus 1. So it will become 2 upon 1 plus e. This will become 2 upon 1 plus e. Right? Okay. Now next part, or next first major application of definite integrals, which is also called area under the curve. This topic is generally read separately in some tuitions or at some places or in some books. This topic is written or given separately, but this is just an application of definite integrals. Integral, if you have learned this in physics also, in physics you must have used this a lot of times. Integral just means area under the curve. That means if I am finding the integration of this function, if this is the complete function, this is the curve of the function, and if I am finding the integral between a to, let's say this is some number, between a to b, okay, if I am finding the integral of function, definite integral of function between from a to b, then that will just give me these areas, this area, this area, this area, this area and this area. It will just give me area under the curve for all this, for the entire curve between 0 to b. I'm sorry, between a to b. Between a to b. Under the curve means bounding the axis and the curve. Area under the curve just means that one. Bounding between the axis and the curve. Under it. Right? If I'm integrating a function and this integrating a function between 0 to b and this is the graph of that function, this is the curve of that function, then integration bit from a to b is just going to give me area under the curve from a to b. That's what it is going to be give me. Very useful in cases of, for example, right? In cos x, the area of one cap is going to be equal to 2 units. So when you integrate cos x from 0 to pi, it is going to give you 2 units. Okay, it is going to give you 2 units. As simple as that. Right? If you integrate one cap between 0 to pi, the result will be 2 units. That's how you are going to get. But now, if you integrate between 0 to 2 pi, it will give you 0. If you integrate between 0 to 2 pi, the result will be 0. Why? Because this is positive, this is negative, plus and minus. So this is going to actually give you a. So when I'm writing this, if I'm writing integral of f of x from a to b, it is giving me a1 positive minus a2 plus a3 minus a4 plus a5. So yes, integration is actually related to area, but this is not exactly area, because a complete area, if you want to actually find the area will be a1 plus a2 plus a3 plus a4 plus a5. All these areas, sum of all these areas. But integration, if the curve is negative, the integration will give you negative answer. That means negative area. Area cannot be negative, right? Scalarly, area cannot be negative, but integration is related to area. It's not exactly giving you the area. It is giving you the area of curve under that interval. That's it. There is a difference in both the things, right? Area under the curve, in that interval it is giving you. There is definitely a difference in both the things. It's not the same thing. It's not the exactly same thing. So it is going to give you, integration is going to give you a1 minus a2 plus a3 minus a4 plus a5. From a to b, if you are integrating, this is what it is going to give you. Right? Suppose for sin x also, actually I made for cos x, it should be for sin. No, yeah, cos x was correct. Cos x was correct. Right? From 0 to 2 pi, I hope you get my point, right? From 0 to 2 pi, if you integrate cos x between 0 to 2 pi, you'll get 0. Why? Because this is going to be 2. But if you integrate between 0 to pi, you'll get 2. If you integrate between 0 to 2 pi, you'll get 0. Why? Because a1 minus a2. 2 minus 2 gave you 0. That's why. That's the reason. Alright. Now, some more major points, like suppose, okay, let's leave, over here, this much is enough. Now we'll understand more with the help of the questions. Now let's understand more with the help of the questions only. Yeah, this thing is written here also, a1 minus a2 plus a3 minus a4 plus a5. So that is the reason. It is related to area, but it is not exactly area only. It's not exactly area. Because area has to be positive always. If we talk about area of something, it has to be positive only. If I'm finding total area of some curve or total area under the curve, it has to be positive only. But here we are getting multiple areas. If the curve is above the axis, or if the curve is positive, we'll get positive integrand. If the curve is negative, we'll get negative integrand. That's how it will work. So that's why. All right. Now, in this section, when we are talking about when we are going to solve the questions related to inverse or sine inverse, cos inverse, tan inverse, integration of sine inverse of sin x, we have not learned it. In indefinite integrals also we have not learned direct integration of sine inverse of sin x. Yes, there can be some methods, but here when we are integrating between pi by 2 to 2 pi, basically what is it asking? Now get the feeling of the concept. It is the first application. What is it actually asking? It is going to ask, it is asking you from pi by 2 to 2 pi, what will be the area under the curve of sine inverse of sin x? We don't know the integral of sine inverse of sin x, but we know the curve of sine inverse of sin x. I hope we know. Getting my point? Do you know the integral of sine inverse of sin x directly? No. but we know the curve of sine inverse of sin x directly. Okay, we know the curve of sine inverse of sin x. So please revise once over here only. You can pause the video or you can drag it behind, but revise curve of sine inverse of sin x, curve of cos inverse of cos x, curve of tan inverse of tan x. These major things you have to revise, because sometimes integral will not be possible, but definite integral will be possible because of the curve, because of the area under the curve that you can find. So sine inverse of sin x, we know how the curve will work. It will be it is like this. Okay, here we have, this is your pi by 2, this is your pi, this will be your 3 pi by 2, and this will be your 2 pi. This is the curve of sine inverse of sin x, sine inverse of sin x. Now when you are finding the integral between pi by 2 to 2 pi, definite integral from pi by 2 to 2 pi of sine inverse of sin x, basically it is asking you the area, this area. Which area? This area, pi by 2 to 2 pi. That means this area, the sum of these two. Now this one will be negative, this one will be positive. So you know how to find it. How much will be this area? This is pi by 2, base is pi by 2, height is pi by 2 only. This is also pi by 2. If you put pi by 2 over here, sine inverse of sine pi by 2 will be pi by 2 again. So what do you have? Total area. That means this will be half of pi by 2 multiplied with pi by 2 minus half. Shall I use another color, right? Half of pi by 2 multiplied with pi by 2 minus half of pi into pi by 2. So how much do we have? This will become pi by 8 minus pi square by 8. Do we have any option like that? A1, this will be A1, this is correct, right? Half into pi by 2 into pi by 2, correct only I have written. Then this is half into pi by 2, correct. Pi square by 8 minus, this is also pi square by 8. Pi square by 8 minus pi square by 4. Pi square by 8 minus pi square by 4 will be your answer. Let me write it. So minus pi square by 8 will be your final answer. Okay, so it's not always that you have to know the integral. In definite integral, you can also understand or solve the question by using the graph of the functions, by using the simple graphs of the functions. For example, this case, f of x is given to you as sin x plus x. If you have plotted minimalistic of the graphs also, you can plot this very easily, right? If you have studied functions, then you know how to plot, and this is very understanding also, x plus sin x. So basically you have to plot, this is y is equal to x plus sin x. So you have to plot sin x graph over y is equal to x. That's how you plot, right? That's how we have learned this in functions. So you have to plot sin x graph over y is equal to x. Y is equal to x will be this line. Let me put it in pink. This is my y is equal to x. Although this is not there in the graph, I'm just putting for the reference. And your sin x is going to be like this. Sin x will be like this. Okay, let's use another color. This will be your sin x. Okay, so this will be the graph of sin x plus x. Now let's come to the question. What is it saying? There is a function fx is equal to sin x plus x, sin x plus x. Then the value of f inverse of x from 0 to 2 pi is equal to. Now if we go and solve this with the, by solving the integrals or finding the, trying to convert this into inverse function first and then integrating it, I don't think it's even possible. There is only one way we can use or reflect or we can solve or approach towards this question is the graph. Do you agree with me? Can there be any other way? Can there be any other way? Will you go on finding inverse of this first? You can. You'll get stuck. Even if you'll not get stuck, you'll take a lot of time. There can be a way, although I take my words back, but yeah, you'll get stuck. Easiest way is to plot it. We know how to plot sin x plus x. Just now we saw, and we know from functions also. So we know sin x plus x. Let's make the line again. My sin x plus x will look like this, correct? This is going to be my sin x plus x. This will be 2 pi. And this will be my pi. And this will be again 2 pi. Okay, this will be again 2 pi. Now inverse of this, this is sin x plus x. So inverse will be just reflection along the axis. So white, alright, white is f inverse of x. White is f inverse x. Okay, this white one will be my f inverse of x. fx is sin x plus x. So white curve will be my f inverse of x. That's it. Same, bounds are same, only pi, 2 pi there also. Now, what is it asking me? Between 0 to 2 pi, that means from here to here, I want the area. Which area do I want? I want this area. I want, which color? Red. Okay. I want this area. This area. Under this curve. Sorry. I want this area under the white curve, right? And this area. Correct? I want this area. This particular area I am looking for. Now you see, here whatever is area of this portion and whatever is area of this portion are going to be the same. Now this is adjusted over here, or we can say this is adjusted over here. So if I subtract this and add it over here, it will be the same thing. It won't make any effect. If I remove this cap from here and put it over here, will it make any difference? No. So basically what am I looking for? I am looking for this particular area, this particular triangle. I am looking only for this particular triangle. In here only, if you put 2 pi, right? If you put 2 pi, you will get 2 pi only again, right? Sin 2 pi will become 0, you will get 2 pi only over here again. So f of 2 pi will be 2 pi. So height, that means this height is nothing but 2 pi. This length is nothing but 2 pi. Base into altitude, half into 2 pi into 2 pi. 2 pi square, directly formed. Okay, 2 pi square will be your area. So we are just finding area. Only with that concept we could solve this question easily, otherwise it will get stuck in our minds or it might get complicated. Okay, so sometimes graphs and the areas are going to be very, very helpful. This is going to be the function of inverse, and this area, I'll explain it once again over here. This area, this complete area we wanted, and this complete area we wanted. exactly, wait, which area we wanted? We wanted this area. We wanted this area under this curve, under the inverse curve. So this portion is adjusted over here. We removed it from here and it put it over here. So complete area will be just this much. Complete area will be just this much. 2 pi, 2 pi, half into 2 pi into 2 pi. That's it. Not a problem. Okay. Although this remark you must have understood by now, there is no need for this remark, but it's just saying that if your function is continuous and when you are integrating your function from a to b, it is giving you 0. There can be two scenarios only. Either the function itself is 0 or function is not symmetric, I would say, but function is similar. Function is somewhat like this. How much ever it is upside, same it is downside, or we can say it is periodic. Periodic, right? It is going up also, and it is similarly same amount it is going down the axis also. Only in these two cases, right? That means from a to b, if you are integrating and you are getting 0, either the function itself is 0 or it is somewhat like this. From a to c it is going up, and from c to b it is going down, and it is giving you a and minus a. This area is a and this area is giving you minus a. Only in these two cases it can happen. That is why it is saying that fx is equal to 0 has at least one root between a to b. That means it is cutting the axis between a to b. Function is having one root between a to b. It is getting 0 somewhere between a to b. Only this can be the case. Now we are coming to properties. Properties again play a major role. Major role means the main role itself is of properties. Most of the question, majorly, I would say 80% or 80 to 90% of the questions which come from definite integrals, either they'll involve indefinite integral, either the indefinite part of that particular question will be difficult, or it will be using the properties of definite integrals. Only in these two cases question can be made difficult. Otherwise equation, they won't give you difficult question. Only differentiation part of that particular question might be difficult. Otherwise you won't get a difficult question in that case. Okay, all right, just a minute. I'll just come in a minute. 2 minutes. Okay, you can revise the previous part. If anything is missing, any part is missing, please revise that. I'll just, and we can start in 2 minutes. Okay, I hope. Properties. There are totally, I think, 6 properties. Okay, we'll go one by one. We'll do questions on one by one. Properties are simple to understand, simple to apply also. The only thing is when to apply which one. Okay, simple to remember, simple to understand, simple to apply also, simple to derive also. Only tricky part is when to apply which one. Right? Application means where we should apply which property. That practice is important. So it is recommended that you solve a lot of questions based on properties. If you are following a book or some module or something, then there if you have separately some questions based on properties, I would say practice them as much as you can, because the major thing in this entire chapter is about properties only. Most of the questions will come from properties only. Okay, if you can master this, then you can guarantee yourself at least one question. Okay, if 2 questions are coming from definite integral, one is involving other concepts. If you're not able to do that, then but your properties are thorough and good, then you can actually solve your question in that particular scenario. Okay, so what are the properties? First 3 properties. Okay, let's just see first how many properties do we have. This is one property. 3 properties, 4th property, 5th property. 4th property has 2 scenarios. 5th property also has 2 scenarios, and then there is a 6th one. Okay, first let's pick up these 3 properties. First 3 properties. What does the property 1 say? Property 1 says that you are integrating something between a to b with respect to x, same function with respect to x, and in the same function with respect to t, you are integrating from a to b. Limits are same. If these limits are same, function is same, so here this integral and this integral will be equal only. There won't be any difference, and you can understand that also. Here we are integrating with respect to t, na? Whatever integral comes out will be same over here. Here x, here t, function is same, limits are same. So integrated with respect to t or x, it will be same thing only. It won't make any difference. Function should be same and limit should be same. That's the main key over here. Second one says that if you change the limits, upper limit made lower limit made at upper limit, if you interchange the limits, then the sign of the integrand, final integrand which is going to come will change. It will be minus over here. Third property we have already discussed, you have already seen, but here there is a catch. Sometimes in some questions you might need to, when we were learning this property, what did we say? That your function is discontinuous at some c between a and b. Okay, if your function is getting discontinuous at some value c, which c is between a and b, then you can break your integral like this, a to c and c to b. But here it is saying c belongs to R. That means it is not necessary that your c should lie between a to b. Even if your c does not lie between a to b and you feel the need of breaking your integral around c and c lies outside a and b, then also it is okay. You can break your integral like that. We'll do some questions. There must be some questions with respect to this also, and this is actually applicable in some specific cases. These two are important, regularly applicable in the while finding definite integrals or questions based on definite integrals. Now over here, first property is going to be used, and one important result which is given over here. This result is going to be useful in questions like this. This is a question from advanced, and only one result, one derivation of the properties itself was useful over here. What is it? What is this result saying? First note this result down, and then I'll tell you the how are we deriving this particular result. How are we deriving this particular result? So what are we doing over here? From a to b, we are integrating our f of x. This is our f of x. What is written? From a to b, f of x dx plus integral of f of a limits are f of a and f of b over here, and in function is inverse of f inverse of x dx. What does this give us? What will this give us? And we have to obtain this thing. We are supposed to obtain this thing. This is what we have to solve. Now, how to solve or how to prove this? Very simple scenario. You just have to put your f inverse x. Put your f inverse of x equal to some t. So, here x will become f of t. X will become f of t. What will be your dx? Dx will be f dash x dt. Dx will be f dash x, f dash t dt. F dash t dt. F dash t dt. Right? Differentiated both sides. Now look again. This is a to b, f of x. Right? F of x dx. Here we had dx. Right? So f of x dx will become f of x dx is dt. Dx is f inverse t dt. So here we'll have f of x into f inverse of x dt. Or instead of writing f inverse of x, I'm just writing t dt because f inverse x is t only. So t into t dt. Right? Next step you can observe. Can you observe the next step? What will this become? F inverse x dx. F inverse x dx, that means t into f inverse t dt. This will become from f of a. What will be f of a? We have taken f inverse x as t. When x is a, f of a will become a. F of a will become a. Or let me write one more step over here. Let me write a f of a only t dt. F inverse x is my t and dx is f inverse t dt. F inverse t is again this thing only. Oh, sorry. F t into f dash t dt. T dx, right? So f dash t dt. 0 to b. Here limits are a to b because f of a. What will be f of a? X is equal to f of t. So when x is a, f of a will become a only, and f of b will become b only. My x itself is f of t. So when t is a, f of a will become a, and when t is f of b, when t is b, f of b will become b only. Correct? Now what? Now here I'll have to apply the by parts. Okay, so this will be a to b, not a problem. Okay, there is lack of space. Space management is an issue. Just a minute. This part is, plus is here. So this part I'm writing over here, a to b t into integral of this, that means f of t again will come between a to b, and this will become minus a to b differential of first, that means 1 into f of t dt. F of x and t dt. Now, 1 into f of t dt. 1 into f of t dt. Now, where are we using the first property? Where were we using the first property? This was f of x dx only, no? Why did we write it like this? This, let it remain f of x dx only. This is f of x dx. This I'm not changing. This I'm writing as it is. Okay, this part, and this part is t into f dash t dt. F inverse x is t, t into f dash t dt. dx is f dash t dt. Then I applied by parts, so it will become 0 to a to b, t into f of t a to b, and here we'll have 0 to b 1 into f of t dt. Now f of t dt from a to b and f of x dx from a to b will be same only. First property we learned just now. F of x dx between a to b and f of t dt between a to b will be same only, same integrand, same value. This and this will get cancelled. This and this will get cancelled. What will we have? We'll have finally this thing. And this is t f of t. This is nothing but t into f of t. This is nothing but t into f of t. Finally, I'm writing t into f of t. So t into f of t will be b into f of b minus a into f of a. This will become b into f of b minus a into f of a. Although you don't need to prove this, you should remember this result as it is. If we are doing f of x between a to b, integrating this, and f inverse of x between f of a to f of b, then and the sum of these two will give us b into f of b minus a into f of a. Right? Direct result should be able to use. Check the limits over here. For example, in this question, 1, 2, right? Check the integrand, like check the function inside the integral, log of 2x cube plus 1, and here we have 2 to the power x minus 1 to the power 1 by 3. 2 to the power x minus 1 to the power 1 by 3. That means inverse of this is over here. If this is f of x, this is f inverse of x. Correct? Now look at the limits. Look at the limits. This is f of x. So what is f of 1? F of 1 will be log of 2 base 2. That means 1. F of a, f of 1. F of b, what will be f of b? Log 2 cube plus 1. That means 8 plus 1, 9. So log of 9 base 2. That will be f of 2. F of 2 will be log of 9 base 2. So this is written nothing but a, same thing is written, a to b, or I should write 1 to 2 plus f of 1 to f of 2, and this is f inverse of x dx. Can we write the result directly? B. What is b? That means 2 into f of b. 2 into f of b. This is f of x. F of b will become log of 9 base 2. Minus a. That means 1 into f of a. That means 1. 2 into log of 9 base 2 minus 1 will be your final answer. You can directly get this. And we have to find greatest integer function less than equal to. So greatest integer function, this will be 1 only. 9 base 2, log of 9 base 2, that means 3 point something, 3 into 2. That means 6 point something. 6 point something minus 1, 5 point something. Greatest integer function of this entire thing will come out to be equal to 5. Will come out to be equal to 5. That's it. Okay. This proof you can remember how to do it. If you don't remember, it's better that you remember this result directly. If we are integrating f of x from a to b, adding it to integration of f inverse of x between a to b only. Oh sorry, between f of a to f of b. In that case, this addition will give us nothing but b into f of b minus a into f of a. Direct result, you should remember, will be helpful in many questions. One mains question was also asked based on this result only. This is one advanced question where you can use this result directly, and it will be definitely helpful. It will be definitely helpful. Now, this one, value of 12 into this, 12 into 0 to 9, mod of x square minus 3x plus 2 dx. Do we know the integration of mod function? And it is not linear inside. Even if you knew the integration of mod function, the function inside the mod is not linear. Function inside the mod is not linear. Now, main thing, we can integrate this very easily. We can integrate this, put the values very easily. Only catch over here is how to know how to open the mod. So we'll look at this function. We'll look at this function where it is negative and where it is positive. Try to check where this function will be negative and where it will be positive. X square minus 3x plus 2. X square minus 3x plus 2. What will be the factors? X minus 1 and x minus 2. So we know the wavy curve. 1 and 2, positive, negative, positive. It will be negative between 1 and 2 only. So how will we break it? 0 to 1, 1 to 2 and 0 to 9 I have written. It is 0 to 3 over here. 0 to 3. 0 to 1, 1 to 2 and 2 to 3. That's it. So we'll break it into 3 parts. 0 to 1. It will open positive because it is positive between 0 to 1. So x square minus 3x plus 2 dx minus integral of, now it will open with negative from 1 to 2, x square minus 3x plus 2. Now again from 2 to 3 it will open with positive because it is positive after 2. So x square minus 3x plus 2. We can integrate it very easily, not a problem. Here also we have dx, here also we have dx, don't forget that. Okay, we can integrate it very easily and find our answer. Right? This will become x cube by 3 minus 3x square by 2 plus 2x. Put the limits 0 to 1 minus same thing, x cube minus 3x square by 2 plus 2. Put the limits 1 to 2 and here we'll have x cube by 3 minus 3x square by 2 plus 2x. Put the limits 2 to 3. Solve this and you'll get your answer directly. Only problem was how to open the mod in this case. So when we have definite integral, it is easier to open the mod because we know where the mod will open with positive sign and where the mod will open with a negative sign. So remember this problem, okay? Easy problem but helpful sometimes. Sometimes, students get hampered or students get confused because of seeing the mod. They see the mod and they're like, no, this is not integrable. We do not know the mod of a quadratic function. We do not know how to open the mod. Direct integral of mod we don't know. But in definite integration, it is easier to solve such type of questions. This thing, okay, this thing only we are getting. Final answer is 22. Now this, look at the question properly once. Properties, okay, properties only we are using over here. Third property we used in the last question. Now here which property are we going to use? Here which property are we going to use? Minus 1 to minus 4 is given to us. 2 to minus 4 is given to us. Okay. And then they are asking minus 1 to 2. Okay. Minus 1 to minus 4 and 2 to minus 4 is given to us. They are asking us the value for minus 1 to 2. What shall we do? Look at this. Minus 1 to minus 4 we have for f of x. If we had f of x only for 2 to minus 4 also, we could solve this. We could use the second property. Right? Sorry, third property. We could use the third property. Not a problem at all. Anything can come. We can break the integral into anything which is not between a to b also. That's what the third property says. That's what the That's what the third property says. Okay. Now, this is how will we get f of x from here? This can be written as 2 to minus 4 3 dx minus 2 to minus 4 f of x dx, which is given equal to 7. What will this become? This will become 3 into minus 4 minus 3 into 2. So minus 12 minus 6 minus 18 minus 18, 7 plus minus 18. So from here what are we getting? From here we are getting f of x dx integrated between 2 to minus 4 is nothing but 7 plus 18, that means 25. This is what we are getting. Okay. Now, first thing that we have is from minus 1 to 4, minus 1 to minus 4, we have f of x dx, which is given to us equal to 4. Second thing what we have is from 2 to minus 4 we have. Can we make it minus 4 to 2? Can we make it minus 4 to 2? Will that be a problem? Will that be a problem? We can make it minus 4 to 2 also, no? We have, what do we have? We have 2 to minus 4. Okay, we have 2 to minus 4. F of x dx, which is equal to 25. So can we not say that from minus 4 to 2, f of x dx will be nothing but minus 25. If we change the limits, if we interchange the limits, integrand becomes negative of each other or sign changes. That's what we can say. Now, if we add our first and second, first plus second, if we add these two, that means integrand between minus 1 to 4, minus 1 to minus 4, f of x dx plus minus 4 to 2, f of x dx. It will give us the minus 1 to 2. It will give us this result, minus 1 to 2, f of x dx. That's what we needed. That's what we needed. This is 4. This is 25. Sorry. Something wrong we are doing, kya? हाँ, 4 plus 25 will get, no? Minus 1 is here. Minus 4 to 2, minus 1 to minus 4, minus 4 to 2, minus 1 to 2 will get. Something's wrong, something is wrong. Array, here we are getting minus 25. Sorry. Wait, here we are getting minus 25. Here we are getting minus 25. This is minus, na? So minus 18 minus 7. That means minus 25 will get. So this will become positive 25 when we'll change the limits. That's what I was thinking. So this will become 4 plus 25. That means 29. This will become 4 plus 25. That means 29. Thank God we didn't have the option of minus 21, otherwise we'll put that. That mistake can happen. Okay, here we are getting minus 25. Understood? 2 to minus 4, f of x dx, we are getting minus 25. This will become minus 18, minus 18 minus 7, and this will go right side. So minus 18 minus 7 will give us minus 25. This will become positive 25 when we'll interchange the limits. Official Cosmos or official Cosmos, you know, you can be restricted from YouTube. I'm sure that you're not studying, but if you're not studying, then doing things like this is totally, you know, not even unethical, but these are ठीक है, नो प्रॉब्लम, ऐसा करोगे वैसा ही भरोगे। गेट माई पॉइंट? समझ में आ रही बात? जिस तरह की हरकतें हम करते हैं ना, वैसी हरकतें हमारे साथ होती हैं, ये फैक्ट है। मतलब ये मैं ऐसे ही नहीं बोल रहा, ये इतना टाइम तक जीने के बाद एंड आफ्टर लिविंग सच यू नो एज्ड लाइफ, जितने भी साल का मैं हूं उतने साल में ये चीज तो मैंने सीख ली है। दिस थिंग आई हैव लर्न, वट एवर यू डू यू पे फॉर दैट, ट्रस्ट मी, दिस हैपन्स। Somebody who's teaching and irritating them or agitating them is the worst karma ever. School mein, you must have seen, no, those students. I had so many friends who used to be like this, who used to just like to irritate their teacher. They'll do something or the other. They'll do something in the class and they'll just irritate their teacher. Teacher will get irritated and they'll have so much fun in that. बहुत मजा आ जाता था उनको कि अरे टीचर परेशान हो गया, बहुत बढ़िया, मजा आ गया, I achieved something. Now I know all of those people who used to do that, and now life is irritating them. That's the irony. That's how karma hits. Okay, anyway, whatever you wish, keep doing. Fourth property, very important property. Some people call it King's rule. Some people call it master rule. There are two rules basically, King's rule and Queen's rule. Fourth property is our King's rule. Sixth property will be your Queen's rule. Master rule and mistress rule also, they say some other names also you'll find, but these are property only and very useful, very, very important, most applicable, I would say. Fourth property says that if you are integrating from 0 to a, very important thing to pay attention over here, 0 to a, right? From 0 to a, limits are 0 to a, then f of x dx between 0 to a will be equal to f of a minus x dx between 0 to a. Same thing. How to prove it? Just put a minus x is equal to t and you'll get this. Put this a minus x is equal to t and you'll get the right side very easily without any problem. You can easily prove it. Okay. Second thing, the second part of King's rule, sometimes it's not, if it's not 0 to a, but if it is a to b, but if it is a to b, then you can write f of x dx between a to b will also be equal to f of a plus b minus x dx between a to b. These both will be same, very important property, and this is majorly used when you don't want some x. Sometimes while integrating, x will be bothering you, an extra x will be bothering you. That's where you use this property. That's where you get to use this property. And one more property is there which we'll be using, but first let's do some questions based on King's rule or the fourth property that we have. For example, over here if this x was not here, then you could integrate it very easily. If this x was not here, you could write in terms of sine and then integrate, or multiply with sine x minus tan x and then integrate. Okay, if you multiply with sin x minus tan x, it will become tan x sec x plus tan square minus tan square x. That you know, both the integrals are standard integrals, you could integrate it in that case. But here x is a trouble. This x is troubling you. Right? This x is troubling you. Now, whenever you have the interval of your integration is from 0 to pi, or not 0 to pi, or 0 to something, and you want to remove an unwanted x to ease your simplification or ease your problem solving related to integration, in that case you have to always use King's rule. Whenever you see an x which is bothering you and your interval of integration is starting from 0, okay, even if it is not starting from 0, sometimes it helps, but as soon as you see these type of limits, first thought which should come into your mind is applying King's rule. Now there is a standard method to apply King's rule also, that we have to learn how to apply King's rule. Okay, that we should learn how to apply King's rule. For example, let's say I call this integral as I. Okay, my I is 0 to pi x tan x upon sec x plus tan x dx. Okay, what does King's rule say? f of x between 0 to a will be equal to f of a minus x between 0 to a. That's what it says. So here, wherever we have x, we can put pi minus x or x minus pi, sorry, pi minus x. This is a, so a minus x, pi minus x will put. So this is going to be equal to between 0 to pi, pi minus x tan of pi minus x upon sec of pi minus x plus tan of pi minus x. Now see how much problem is actually resolved. How the problem is actually resolved. One more step is there. You have to apply that. After that, you'll understand how the problem is going to be resolved. Tan of pi minus x will become tan x only. So instead of tan of pi minus x, just let me write. Oh, minus tan x. Sorry, minus tan x it will become. It will become minus tan x. Sec of pi minus x will become sec x. And again tan of pi minus x will become minus tan x. Okay. Now, if you take minus common from here, this will become plus, and that minus and this minus will get cancelled. So let's simplify it over here only to reduce the space, to use the space carefully. Now what is this? This is your, these are same integrals, both are same integrals. Add both of them. Second step, pay attention carefully. Second step of King's rule is add both of them. Very good. Add both of these, I plus I. So what will you get? You'll get 2i. As soon as you do 2i, this will be 0 to pi only. Denominator is same, which is sec x plus tan x. What will be the numerator? X tan x plus pi tan x minus x tan x. So x tan x minus x tan x will become 0. What will you have? You'll have pi tan x. X got removed. That x only was your problem. X got removed. Applying fourth property or the King's rule is like this. Whenever you are applying, you have to add both the results. After substituting x as a minus x, here a is pi, right? You have to add both the results, and after that you will see the magic. After that you will be able to see the magic. So this is what we get. We get 2i equal to 0 to pi. Pi will come out here. Pi will come out. So let me write 0 to pi. What do we have? This will become either convert it into sin x cos x or multiply sec x minus tan x in the numerator and denominator. So numerator, when you will multiply sec x minus tan x, what will you get? Tan x sec x minus tan square x. Denominator will be sec square x minus tan x square x, which will become 1 only. Which will become 1. Correct? Any problem over here? Till here? No problem. Here also I we need to find. So this 2 also we can send on that side. We'll make it pi by 2. So what is our I? Pi by 2. Now we know the integrals. Now we know the integrals. Tan x sec x will become, we know sec x tan x also. Okay, let me write one more step. 0 to pi sec x tan x dx minus 0 to pi, this whole thing with pi by 2. 0 to pi tan square x dx. Okay. Both are standard integrals. Tell me the answer. This you can break as sec square x minus 1. This will be nothing but pi by 2. This will become sec x, right? So sec x directly from 0 to pi, you have to put the limit, minus sec square x or minus integral of sec square x 0 to pi minus 1 0 to pi 1 into dx. So this you can find easily. This will become pi by 2 into minus 2 minus tan x, which will be again between 0 to pi, plus x between 0 to pi, which will be equal to pi into pi minus 2, and finally we'll be getting pi into pi by 2 minus 1. This will be your final answer, right? This will be your final answer. These are standard integrals. After this, you can solve on your own. I've skipped some steps. Let's check the answer once. Yes, pi into pi by 2 minus 1 are we getting. This is what we are getting. Now some more examples. Mostly in trigonometric cases, or whenever we see 0 to some limit, 0 to some, a is the limit. In those cases, we should use. For example, first case. Now we can see cos of pi by 2 minus x will be sin pi by 2. Sin x. Cos of pi, here also cos pi by 2 minus x, sin pi by 2 minus x, cos x. So we are getting same things when we are putting, instead of x, we are putting a minus x. A is pi by 2 over here. Correct? So that means King's rule is going to be used over here. That means we should be using King's rule in such cases. So as I said in the starting also, it is very important to understand when to use which property. And most of the times, hints will be given to you. For example, these are revolving function. Revolving function means we are getting same things, almost same things, or exactly same things, but on applying sine of a minus, f of a minus x. So that means King's rule is going to be applied. So simply, what is my I? I is given to me as 0 to pi by 2 cos x upon cos x, or instead of writing cos x, okay, plus sin x dx. Alright. So this I can also be equal to 0 to pi cos pi, pi by 2. Yeah, pi by 2. Cos pi by 2 minus x, that means sin x, upon cos pi by 2 minus x, that means sin x, plus sin pi by 2 minus x, that means cos x. As soon as I'll add, I'll get 2i equal to 0 to pi, right? Same denominator, sin x plus cos x, numerator also cos x plus sin x. So what am I getting? I'm getting 0 to pi 1 dx. That means x 0 to pi by 2, not pi by 2. So my answer is nothing but x only, right? So I'm getting pi by 2, which is equal to 2 times I. So my I will become again pi by 4. This will be my integral, final integral. That's how King's rule is applied, and it is very, very useful in some specific cases. Okay, pi by 4, correct. In this case, again, when you see 0 to something, first thought should be, let's apply King's rule, right? 0 to something, that means first thought which should come in your mind should be the King's rule, that I can apply King's rule or I can try King's rule. Isn't it the same problem actually? This is the same problem as the last one. Put sin by cos over here. So this will become cos x plus sin x. Cos x will be in the numerator. Same problem. Same as last. Again, answer will be pi by 4 only. Pi by 2 is the limit, so pi by 4 will be your answer. Right, same as the last one. In this case, is this also same as the previous ones? No, but revolving functions again. Right, can we see the revolving functions again? And we see 0 to pi by 2. Cot of pi by 2 minus x will give us tan x. Tan of pi by 2 minus x will give us cot x. So revolving functions, apply King's rule. So what we'll do, 0 to pi by 2. Even if square root is there, not a problem. Right? Even if square root is there, not a problem. When you can see revolving functions, this will become tan x upon root of tan x plus root of cot x. What do we get? This is also our I. This was our I plus I, 2I will become equal to 0 to pi by 2, 1 dx. Again, your answer will be pi by 4. This will also give you pi by 4. Application. Right? Application of King's rule should be visualized. Either King's rule or one more rule is there, sixth property, which is Queen's rule. Both of them are either combinedly used or separately used, but you should be able to see where I can apply. Here is one more example where you can apply King's rule, because as soon as you see 0 to something and revolving functions, problem is from advanced, because one more thing which is going to be used over here, that is there. Otherwise, this problem is of King's rule, and first step is already known to you, that you have to apply King's rule, that you are supposed to apply King's rule over here. Alright, so what will be your I? I will be equal to 3 will come out, 0 to pi by 2 and cos theta. So I'll write first, okay, root cos theta divided by root cos theta plus root sin theta. I'm writing not the given integral first, to the power 5 d theta. This power 5 is a trouble, but still first feeling, first thought which should come in our mind is that King's rule is being applied. Then we'll see what is happening or how can we move further. Okay, this is your I. Again, now apply King's rule. It will become 3, 0 to pi by 2. This will become sin theta. Cos of pi by 2 minus theta will become sin theta, divided by square root of sin theta plus square root of cos theta to the power 5. Right? D theta. D theta. Add both of them. What do we get? 2i will be equal to 0 to pi by 2 cos theta, root cos theta plus root sin theta, root cos theta plus root sin theta divided by same denominator, root cos theta plus root sin theta to the power 5. Now the catch is at least one power got cancelled. This is cancelling it 1 and it is remaining 4 only. Now what do we have? We have 2i equal to integral of 0 to pi by 2. One power got cancelled, you can see that. Hey, at least one power got cancelled. So this is now d theta by square root cos theta plus square root sin theta to the power 4. Now the question is only of, here there was a 3, so instead of this I equal to 3 by 2 I'm writing. Okay, there was a 3 over here. There was a 3 over here. 3 was there. Okay, now this is only of indefinite integration. This is, now the question is no more of definite integration, it is purely of indefinite integration. Correct? So if we can, so if we just have to use indefinite integration and solve it. The role of properties and the role of definite integration is over. How do we solve it if this question was given in indefinite? We'll take root cos theta common over here. Root cos theta will come out. Root cos theta to the power 4 will give us cos square theta. Right? Cos square theta. Inside what will remain? Root of tan theta plus 1 to the power 4. Okay, root of tan theta plus 1 to the power 4, and we can also take this cos square theta in the numerator because it is giving us integration of tan theta, so d theta. Okay. Now either put tan theta equal to t or put tan theta is equal to t square, and you can solve this question. Now just do simple substitution, put tan theta equal to t square, and you'll be able to find the integral of this, indefinite integral of this. Simply you can find, let's see, tan theta equal to t square, till here we had got correct, right? 3 was out, sec square theta upon 1 plus root tan theta to the power 4 we are getting. Put tan theta equal to t square, differentiate both the sides, sec square theta, d theta will become 2t d theta. This will become 3 by 2, let it remain outside only, t d theta upon 1 plus t to the power 4 plus t you will get. So plus t by t plus 1 to the power 4, linear by non-linear, that means plus 1 minus 1 you will have to do, right? So plus 1 will give you, this will break over here and it will make it 2 into 1, t plus 1 whole square in plus 1 by 3 into t plus 1 whole cube, 0 to infinity. 0 to infinity because tan pi by 2, when you are substituting, so t, when t becomes pi by 2, tan pi by 2 will give you infinity. Don't worry about infinity also. Here this will become 0, this part will become 0, upper limit, this part will become 0, this part will become 0. You only have to look for 0, right? When you put infinity over here, this will become 0, this will become 0. So entire thing will become 0. You only have to check with 0. So when you'll put 0 over here, this will become 1 by 2 and this will become 1 by 3. Final answer will be 0.5, right? So without indefinite integration, 99%, 95% at least, 99% questions of definite integrals you cannot solve by having grip over, without having grip over indefinite integration. Now this question, limits are not 0 to something. Limits are not 0 to something. It was, if it was only 1 plus sin x, we could go for solving it with normal indefinite integration. We know the approach for solving 1 by 1 plus sin x. But here it is x by x plus sin x, x by 1 plus sin x. That is an issue. Can you see it? If it was only 1 by 1 plus sin x, we could solve it. Problem is created because of x. Okay. And just now we have learned King's rule. We also saw that 0 to a, also for 0 to a also we can apply f of a minus x. But if it is a plus a to b, then we can apply f of a plus b minus x. And you can see a plus b is beautiful. Pi by 4 plus 3 pi by 4 is pi. Correct? Pi by 4 plus 3 pi by 4 is pi. And instead of x, if we had pi, it will be much easier for us to integrate this. So we'll apply the King's rule. Let's say this is your I is pi by 4 to 3 pi by 4 x by 1 plus sin x dx. Okay. Applying King's rule, what do we have? Pi by 4 to 3 pi by 4, not a problem over here. Okay. Instead a plus b minus x, instead of x we'll put a plus b minus x, so this will become pi minus x. A plus b is pi and pi minus x we'll have. Here what we'll have, 1 plus sine of pi minus x. Sine of pi minus x. Sine of pi minus x will again become sin x only, right? This we know how to integrate. This will become your, okay, after adding, we'll add, right? We didn't add till now. We'll add. So on adding, what do we get? On adding, we get 2i equal to pi by 4 to 3 pi by 4. Add these two. Adding these two. So x plus pi minus x will just have pi now in the numerator. Denominator will have same denominator, so 1 plus sine x. Now it's your wish how you want to solve it. You can multiply. Now two terms are there. If we had only cos square x, it will be much easier. What we'll do, we'll multiply and divide with 1 minus sin x, right? Multiply and divide over here with 1 minus sin x. Denominator, sorry, 2i will become equal to, pi will remain outside, from pi by 4 to 3 pi by 4, 1 minus sin x upon cos square x. What is this? This is, now we know, right? Now we can solve. What is this? This is sec square x, which we know, and this is sec x tan x. That also we know. Both the integrals we know. This becomes sec square x minus sec x tan x. Both the integrals we know very easily. Correct? Sec square x also we know will become tan x, and this will become tan x into sec x, which is again sec x. So both the integrals we know. Let's see. 1 minus sin x cos square x, sec square x minus sec x tan x. This becomes tan x from 3 pi by 4 to pi by 4, and this becomes sec x from 3 pi by 4 to pi by 4. Minus sec x, right? Minus is here, so minus sec x will become. Final answer will be this thing. Just put the limits and get your answer. One question, one PYQ. Look at the problem. Problem looks horrible. Too many logs and all over here. We can see 2 to 4, but then again there are so many things. Achha, one thing I want to ask you, log x to the power 2 can be directly written as 2 log x? No, right? What is it written as? It is written as 2 log of mod x. If you have done the function in logs especially properly, then you remember that it is written as 2 log of mod x, right? So that mistake can happen over here, but here x is between 2 to 4. So that means we don't have to actually write mod of x. We can directly write x. It will be positive only, right? It will be positive only. One point is that. Another point which you have to observe or pay attention at, this thing. What is this? This is nothing but 6 minus x whole square. 6 minus x are so what? Arey baba, 4 plus 2 minus x. A plus b minus x. King's rule. Right? As soon as you could see this, you could have solved this question very easily in seconds. Correct? But if you could not see this, then this question might confuse you. But yeah, seeing this is not a problem. If there is a quadratic, you can actually see very easily. It will come in like in some 10 or 15 seconds, it might come into your mind, but it will come into your mind. And as soon as you see 6 minus x, then your problem is solved, because you know now I have to just apply King's rule and nothing else. Am I correct or not? Correct? Here you just have to apply 6 minus x. Now because your x is between 2 to 4, that's why here you can write 2 log x. This can be written as 2 log x. No need for writing 2 log mod x. Otherwise, log x square is 2 log of mod x. But here, because x is between 2 to 4, you are directly writing log of x. Right? 2 log x. Here also 2 log of x plus 2 log of 6 minus x. Okay. So these 2's get cancelled. This is your I. Now log x upon log x plus log of 6 minus x. Apply the King's rule. 4 plus 2 minus x. So this will become log of 6 minus x. Here also what we will have? Log of 6 minus x. Okay, and here we'll have 6 minus 4 plus 2 minus x. That means log of minus x only, right? Log of plus x. Log of 6 minus x. That means plus log of x. Now what? Add both of them. Now just add both of them. 2i will become 2 to 4. This is from 2 to 4. Log of x plus log of 6 minus x divided by log of x plus log of 6 minus x. Log of x plus log of 6 minus x, numerator, and denominator will be same only. This and this are same. So log of x plus log of 6 minus x. What do you get? You get from 2 to 4 1 dx. This gets cancelled, 1 dx. So nothing but 4 minus 2. That is going to give you a 2 only. Right? But remember, 2 is not your answer. 2 is equal to 2i. Right? Sometimes if it is integer type, then don't mark 2. Remember this thing. So many times I have seen students making this mistake. This final answer might be equal to 2i. So check that. This 2 is equal to 2i. So your I will be equal to 1. This will be your answer. Final answer will be equal to 1, not 2. I was also about to make that mistake, although. But yeah, remember this. So what was the catch over here? Looking at this and then relating it with the King's rule. Simple application of King's rule. Very easy answer, but yeah, you have to relate it likewise. Let's see one more problem. Acha, whenever you see e to the power x, no, this particular category is a special category. Many times similar type of question is asked, and there is a simple observation over here. Whenever you are seeing exponential function e to the power x or e to the power something you are seeing, and your limits are adding up to 0, that means it's a good thing. That means it's a good thing. That means it's a question of King's rule. Directly a question of King's rule and nothing else. Note this down. If your limits are adding up to 0 and you have an exponential function over here, right? In that case, you should go ahead with applying the King's rule. You can note this down somewhere. Okay. Because a plus b minus x will make it much simpler. Will make your problem much simpler. What is your I? This is, let's say this is your I. And on applying King's rule, when you apply King's rule, what will you get? From minus pi by 2 to pi by 2. This will become 0 minus x whole square. So minus x ka whole square. Cos of minus x. This will become 0 cos of minus x. Right? Let me write the complete thing once. Cos of minus x. Upon 1 plus e to the power minus x. Now sir, how did this help me? Check once. First solve this. This is also your I, and now add. Second step of King's rule is addition. So 2i, what will 2i become? 2i will be minus pi by 2 to pi by 2. Add this. What are you getting in the numerator? Or before adding this, let me write this. This is minus pi by 2 to pi by 2. X square cos of minus x will be cos x only. And here we'll have, this will be 1 plus 1 by e to the power x. So 1 plus e to the power x and e to the power x will go over here. E to the power x will go over here, and we'll have 1 plus e to the power x. Correct? Now this and this you are supposed to add. This and that. This and that. This and this you are supposed to add. So 2i will become x square cos x will come out common. X square cos x will come out common. What will remain inside? 1 plus e to the power x upon 1 plus e to the power x got cancelled. You are just integrating this much, minus pi by 2 to pi by 2 x square cos of x. And here nothing but by parts. It'll be, you'll have to apply by parts. Please apply once on your own or revise from the last lecture. Just apply by parts, and this is simple indefinite integration problem. Okay, I'll show you also. It must be there in the solution. How did it become 0 to pi by 2, bhai? What have they done? Okay, this is a mistake. This is a mistake over here. But use integration by parts. So integration of first into integration of second minus integral of derivative of first into integration of second. So finally you are getting this thing, and this should be from minus pi by 2 to pi by 2, not 0 to pi by 2. I don't know why have they written 0 to pi by 2. It's not changing also anywhere. Acha, minus a to a ko they have broken it like this. They have used a property which is going to come ahead, because cos x is just a minute, there is some problem. Acha, cos x is actually a periodic function. Cos x is a periodic function. So from minus pi by 2 to pi by 2, it will have same graphs 2 times. So that's why they have written. But you don't worry about this property. Without this thing's knowledge also, simply if you will apply by parts, you will get the answer. Okay, by parts simply if you will apply from minus pi by 2 to pi by 2 also, then also you will get the answer. You will get a bit longer answer, longer calculation will be there, but you will get your answer. No need to use this. They've used a property of periodic function. Periodic function means cos x is periodic from 0 to 2 pi, no, from minus pi by 2 to pi by 2. So that's why they've used that property, but you don't need to use that. Nowadays it's not used that much also. That's why I didn't keep. Okay, property 5 and property 6. Property 5 is simple to understand. Actually, property 5 only they have used over here. See what I was talking about. This property 5 they have used. I'll explain you what property 5 is. If your function is integrating between minus a to a, okay, if your function is integrating between minus a to a, and your function is an odd function, right? If your function is integrating between minus a to a and your function is an odd function. Odd function means whatever it is on this side will be same on this side. Okay, whatever it is on this side will be same on this side. So this area and this area will add up to 0, right? If your function is an odd function means whatever it happening on this side will same thing will be happening on this side. So when you'll integrate from a to b, in that, sorry, minus a to a, okay, on the left side and right side. So minus a to a, if you'll integrate, when you'll add this total sum, integration means sum of areas, positive and negative with signs. Sum of area will become 0 because it is an odd function. From minus a to a, it will be similar on both the sides. Okay, function is even function. If the function is even function means from minus a to a, it is something like this, right? Even function and odd function, I hope everybody is thorough with. If you're not, how much more is left? Aryan, if you guys are tired or you want to take a break, it's okay, take a break. Watch the lecture afterwards, not a problem. Okay, if there are any doubts also, if there is anything which is missed, which went wrong, which you wanted an extra opinion on, put it on the comments. Either I'll reply on the comments or I'll take that thing in the next session. Okay, as I told you in the starting, we are going to bring up with a very interesting and important thing by the next week. Okay, I'm not going to reveal it, what's going to be there, but very productive thing is going to come up by next week. All the 3 teachers, physics, chemistry and maths, all the 3 subjects are going to be taken care of for all the 2026 aspirants especially. For 2025 aspirants, whatever you need, keep posting in the community post, you can comment, or on the videos you can comment, sir, this is what we need. And as much as we can do, we'll do that for you guys. Don't worry about it. Okay. So I was saying, if it is an even function, then this integral will be twice of this. The result will be twice of this. This means 0 to a. This is from minus a to a. So twice of this. Twice of 0 to a. Twice of integral from 0 to a of f of x. If f of x is even function. Why? Because of this. Because you can see, even and odd functions, graphs and everything, you should know to understand this. If you don't know, revise that part and then come to this, you'll understand what I'm trying to say. If it is an odd function, it is going to look like this. Positive and negative, both sides will be there, and when we'll add, we'll get a 0 from minus a to a. But if it is an even function, from minus a to a, it will look like this. When we'll add, it will just become twice of one part, which is from 0 to a. That is what they have used. And x square cos x is an even function. It's not an odd function. X square cos x is an even function. F of x is equal to, f of minus x is equal to f of x. That's how we see what is even and odd, right? If f of minus x is equal to minus f of x, that means odd. If f of minus x is equal to f of x, that means even function. Correct? So that's how we check. For last question, we could use that also, and fifth property. So revise last question again using this, or directly apply by parts as you wish. All right. So this is the fifth property, very important property. Sometimes when you can realize the graph, when you can easily see which type of function it is, even or odd, in those cases, it will be really helpful. But you should be able to see whether the function is even or odd. That trick is definitely over here, right? If your f of, I'll just write over here also. If your f of just for revision, although you should revise the complete part, all the 3-4 questions you should do for even and odd functions to understand this property, but I'll write the basic definition. If f of minus x is equal to minus f of x, correct, then your f of x is odd. And if your f of minus x is equal to f of x only, then your f of x is even, then your function is even. I'll just write that, so that in the upcoming questions also, if you want, you can apply that. Okay, now see, first one, which type of function it is? Try to check with the definition. This is simply an odd function. This is an odd function. From minus a to a, if we are integrating an odd function, answer will directly be 0. That's it. Many times this thing will definitely help you all. This is an odd function. F of minus x is equal to minus of f of x. Check, f of minus x will be equal to minus of f of x. Put x as minus x over here, you'll get minus of this function. So this is an odd function, and minus a to a, if we are integrating a function from minus a to a, if we are integrating an odd function from minus a to a, in that case we'll surely get a 0. Fifth property. Okay. So you should be able to see which type of function it is. Now, when to apply this property? Whenever you see limits like this, minus a and a. That means something related to even and odd function is being used. That's the catch, or that's the method to identify that we are supposed to apply this particular identity. Okay. Now, this here we are not able to directly see whether function is even or odd. If you want to see, you'll not be able to check directly. So what to do in that case? So in that, but we know that something related to fifth property is going to be used, because limits are minus a to a. Now see, we know, if we have studied functions carefully, we know 2x upon 1 plus cos square x. This will be an odd function. You can check, f of minus x will come out to be minus f of x. Right? This is an odd function. But where is this? This is not completely. this is not the only thing inside the integral. There is something else also, right? There is something else also. Now when we see, okay, let's write first. Let's say our integral is, let's break our integral like this, minus pi to pi, okay, 2x upon 1 plus cos square x, which we know is an odd function, plus minus pi to pi 2x sin x upon 1 plus cos square x. This is how we can break it, and here we get one relief, that this is an odd function, so this will become 0. This will pakka become 0. Now what about this? 2 will come out. Integral of, sorry, wait, one more thing. This particular function, if you want to check, this is not an odd function. Check f of minus x, put f of minus x over here, you will get f of x only. 2 into minus x into sine of minus x, 1 plus cos of minus x square. We are getting again the same thing, sine of minus x will become minus sin x, again same function we are getting, that means it is an even function, right? This is an even function. But when we have an even function, we don't get 0, but still we have something to do with it, right? So this will become 0 plus 2 times of, limit will become from 0 to pi, minus pi to pi will become 0 to pi, 2 times of this integrand, 2 times of this, 2x sin x upon 1 plus cos square x dx. So 2 into 2, this also I am removing, this will become 4. This will become 4. Correct. Now how to do this? Now whenever you will apply even functions property related to even function, one good thing will happen. What will happen? The limit will become 0 to pi. And as soon as the limit becomes 0 to pi, what should come into your mind? What thought should strike your mind? Sir, only one thought. 0 to pi means King's rule can be applied, and we can see convertible functions are over here. Okay, so King's rule, first thought should be King's rule. Let's apply King's rule. That means fourth property. I'm saying King's rule. I don't know what you have in your how that is odd. I told, right? Which one is odd? Put, instead of x, put minus x. Same function will come with a negative sign. If f of minus x is equal to minus f of x, that means odd function. Huh? Correct. Good. You guys help each other. Okay. So this is your, now 0 to pi, that means King's rule will be applied. King's rule means instead of x, put pi minus x. Instead of x, put pi minus x. So this will become 4 times of 0 to pi minus x, sine of pi minus x, again sine x, divided by 1 plus cos of pi minus x, cos x only, cos square x. Okay. Now add this one, this and this. Add both of them. So you have 2i. I'll write add once. Add. I'll write this as first equation and this your second equation. Add 1 and 2. Add 1 and 2. What will you get? You'll get 2i equal to 4 times of 0 to pi x sin x plus pi sin x minus x sin x. So you'll get pi sin x upon, denominator is same, 1 plus cos square x. This you know how to solve, right? So this will become I equal to 2 pi 0 to pi sin x upon 1 plus cos square x. So just take cos x is equal to t, its integral is sin x, and you can solve. You can solve by taking cos x equal to t. Put cos x equal to t, and this is just a question of indefinite integral after that. Just put cos x equal to t. This will become d minus dt upon 1 plus t square, right? 1 plus t square is a known integral. Okay. We have that over here, x sin x. Okay, this was 2y we got as 4 pi into 0 to pi sin x upon 1 plus cos square x. Put cos x is equal to t and you will be able to solve. How have they done? Minus 2 pi, okay. Right? They have done the substitution only, just missed some steps. But do it with putting cos x is equal to t and you will be able to solve. Now, sixth property, which is also called Queen's rule. The sixth property, which is also called as the Queen's rule. Again, similar to King's rule, only Queen rule is also very applicable, and it is definitely very, very useful in many cases, in many scenarios. How to apply this? When to apply this? Actually, you have to make a connection, or sometimes you'll have to make a connection between King's and Queen rule. Suppose you have 0 to 2a. I'll explain what is Queen's rule. The limit is from 0 to 2a, and you want to break your integrand into two parts. Break your integral into two parts. How will you break? You will break it like this: 0 to a f of x dx, and then same 0 to a f of 2a minus x dx. Okay, f of 2a minus x dx. So this will just become this thing. This will become 0 to a f of x plus f of 2a minus x dx. This entire thing dx. This is what is written over here. Okay, this is what is written over here. And now this part, I'll come to this part. Now when to use Queen's rule? Whenever f of 2a minus x is giving you either same f of x or it is giving you negative of f of x, right? If your f of 2a minus x is giving you negative of f of x, that means f of x minus f of x, this will become 0. Useful. So you have to check what is 2a minus x giving me. If your f of 2a minus x is giving you f of x only, this will just become 2 times of f of x. 2 times of integral of f of x, or 2 times of 0 to a integral of f of x, then you can apply King's rule. We'll come to questions, but here I'm just explaining how to know whether I have to use Queen's rule. When either you one case can be you want to break your integral, which is not the case, 0.001% chance that you have to break the integral like this. Most of the times, if you are able to see that your f of 2a minus x, that means f of 2a minus x is giving you same f of x or minus of f of x, in that case you should go for Queen's rule. In that case, this problem will become very, very easy. Let's look at it by some questions. Okay, yeah. For example, over here, 0 to 2 pi is given to you, right? You saw 0 to 2a, this will become 0 to a, 0 to a, right? 2 times, if same f of x is coming, then 2 times of 0 to a, f of x dx. If minus f of x is coming, then 0. That's it. Direct answer will become 0. Now over here, 0 to 2 pi is given to. 0 to 2 pi is given to. Not every time they'll give you a multiple of 2, and it will not be very clearly visible every time to you. You'll have to analyze. As soon as you see something like this, one thought can be applying King's rule. Achha, applying King's rule 2 pi minus x, cos of 2 pi minus x sin x, it is giving you. Okay, sin x it will be giving you. Any use of that? Is there any use of that? Cos x minus sin x won't give you anything. Cos x plus sin x won't give you anything. Just a minute, please. There is, I'll just take, just try to relate, try to apply Queen's properly over here. I'll take a small break. I'll take 2 minutes break. Okay, I'll just take a small break. Try to apply Queen's rule over here and try to relate it. Try to solve it with what we just learned. I'm sure you will. Hello, hello. Oh, where did the... It got too late, kya? Oh, ho. I'll have to start it again. So sorry. We did all this. This. Okay. We were on property 6. Property 5 done. Yes. Property number 6. Yeah. This is what we were at. And I'm extremely sorry for taking a bit longer break. But I hope you guys understand that it was quite needed. It was unavoidable. Otherwise, I wouldn't have taken. Yeah. So this was the property. Let's discuss this once again. So whenever you have something like 0 to 2 pi, or you have something from 0 to 2, and you are able to check that your f of x and f of 2a minus x, just check f of x and f of 2a minus x. Whenever you have this, now to see, if you have 0 to something, simple thing, 0 to something, that means two rules can be applied, either king or queen. When to apply queen? To check whether I can apply queen rule or not, just do simple thing. Check f of 2a minus x. If your f of 2a minus x is coming out to be equal to minus f of x, that means you are going to apply Queen's rule, because you are going to get 0. Right? F of 0 to 2a can be written as 0 to a f of x plus 0 to a f of 2a minus x dx. This is what Queen rule says. And if this thing is equal to minus of f of x, right, in that case this entire thing will become 0. If this f of 2a minus x is equal to f of x again, then this entire thing will be equal to 2 times of 0 to a f of x dx. So for Queen's rule, you have to check for f of 2a minus x. What is that giving you? That's the simple catch. Okay, for example, let's see this problem. Now 0 to 2 pi, right? First I'll simply write my I is equal to 0 to 2 pi cos of 5x dx. Right? In rough, what I'll do, I'll just check what is my... Yeah, one more thing which I didn't tell. When you'll be checking f of 2a minus x, you have to check it for 0 to a. Okay, 0 to a. So here we'll be checking, here we have 0 to 2 pi, we'll be checking for 0 to pi. What is cos of 5x plus 0 to pi cos of cos to the power 5 2 pi minus x is giving me. Right? Now, cos of this what will this be? Cos of 2 pi minus x. This thing will again be cos of 5x, cos to the power 5x. This will be same only. Okay, so now what does it mean? This is giving me same f of x. So now this thing I can write simply as my I will become equal to 2 times of 0 to pi cos to the power 5x dx. That's it. Now what to do? Should I apply King's rule over here, or shall I continue with Queen's rule? To check Queen's rule, check in the rough. What is this giving you? Now this is 0 to pi, right? We have here we had 0 to 2 pi, we checked for 0 to pi, 0 to pi. Here we have 0 to pi, so we'll check for 0 to pi by 2 cos to the power 5x plus 0 to pi by 2 cos to the power 5 pi by 2, sorry, not pi by 2, pi minus x. 2 pi, right? 2 pi. So 2 pi will be pi minus x. And now this is giving me minus cos to the power 5x. Cos of pi minus x will be minus cos x, right? So here I am getting negative. So now this thing will eventually become 2 times of 0 to pi into 0 dx. My final answer, which will come out to be 2 into 0. 2 into 0. Why? Because this is minus cos of 5x. This is becoming 0. This can be written like this, which is giving us a 0. Which is giving us a 0. Right? These two adding up are giving us a 0. So applying Queen's rule was helpful over here. Right? King's rule, if you see, King's rule, if you will apply, so directly you can see, right? Cos of 2 pi minus x. Right? Instead of x, you will apply cos of 2 pi minus x. When you will add, you will again get 2 into cos of 2 pi minus x. Cos to the power 5 x dx. 2 into same thing you will get. What will you do with King's rule? So applying King's rule is not, you can see that it's not worthy over here, or we are not going to, it's not going to help us over here. Queen's rule is going to help us over here, and in rough you have to check for Queen's rule. Break this with 0 to pi to 0 to pi. If it is 0 to 2a, then break it into 2. 0 to a of f of x and 0 to a of f of 2a minus x. That's how you can check. Let's apply it in a couple of more questions. For example, this question. Right? For example, this question. I1 is this and I2 is this. Then we have to find a relation between I1 and I2. Some relation between I1 and I2 we have to look for. So look at the limits. 0 to pi is there, and then pi into 0 to pi by 2 is there. So let's say I'll solve either one of them and will try to navigate from one to another. Either I'll solve I1 and move towards I2, or I'll solve I2 and move towards I1. That's what I can do. That's the simple approach. So I'll start with I1, let's say. Let's say I'll start with I1. My I1 is 0 to pi x f of sine cube x plus cos square x dx. Now what should I apply? It is 0 to pi. Correct? 0 to pi. If I'll apply Queen's rule, pi by 2 will come. Sine pi by 2 cos pi by 2 sine. Same thing is coming up. Correct? It's not helping me anywhere, right? And here what will I get? Here what will I get? Here I'll get x only. Here I'll be getting x only. Oh sorry, pi by 2 minus x. If I want to apply it, here first of all x is going to create me a trouble. So 0 to pi, first thought is, it's not a multiple of 2, I'm not having 2 pi over here. So first thought is that, okay, apply King's rule, because we have seen if it was 2 pi, then first thought would be that, okay, apply King's rule. But here first thought should come as will be apply King's rule. Okay, so I'll apply King's rule. So my I1 will be equal to 0 to pi. Instead of x, I'll put pi minus x, a minus x, that means pi minus x, into sine pi minus x, right? Sorry, f of sine cube pi minus x, so sine cube x only, plus cos cube pi minus x, that means cos cube x only, cos square it is, right? Minus cos cube x, but square it is, so cos square x only. Minus cos square x, but it is square, so again same thing is going to come up. Now according to King's rule, I have to add both of them. 2i1 will become equal to 0 to pi x this will become x minus x will become 0, pi will come outside, right? This will come common, pi will come outside, so pi over here, let's say, okay, no, let's take common only, pi will come outside, and this will, same thing will get added up, so sine cube x plus cos square x, and this with dx, same thing came up. King's rule did not help me. 2i is coming equal to this. Do we have something like this? Now in I2 you can see pi by 2. Now what do you want? You want to move from I1 to I2. So you have to change the limit and change the limit to pi by 2. Pi came out already. Pi has come out already. Using King's rule, your pi came out, but this limit should be changed. You need to change this limit. So here you'll apply Queen's rule. Now to break the limit into half, you'll have to apply Queen's rule. Second step should be, here you can apply Queen's rule because you want to move in this direction. Here it's not completely this. Here it's not completely this. Same thing, but limit is different. So to make the limit like that, what will you have to do? Your 2i will be equal to 0 to pi by 2. Okay, f of sine cube x plus cos square x dx plus f of same thing will come, pi by 2, sine pi by 2 minus x will give you this, cos pi by 2 minus x will give you the same thing, correct? And here you will have a 2, so same thing is coming, f of x only is coming, so that means 2 times of this, right? If you will apply pi by 2, 2a minus x, pi minus x, if you will apply, same thing will come up again because it is cos square, right? How will you break this? How will you make a limit pi by 2 over here? I've just not written one step, I'll explain it again. So this was your 2i, this was your 2i, here was one more pi, 2 pi, wait, here we had a pi, this is your 2i. Now when we made the limit pi by 2, 0 to 2a, if we are integrating f of x from 0 to 2a, how do we write? 0 to a f of x dx, which is this, 0 to a means 0 to pi by 2, 2a is pi, so a will be pi by 2, 0 to a f of x dx plus 0 to a f of x, 0 to a f of 2a minus x dx. What is f of 2a minus x giving us? F of 2a minus x, that means f of pi minus x. So sine of pi minus x, sine x, sine cube x only. Cos of pi minus x is minus cos x, but it is cos square x. So again cos square x will come. So same thing is coming up. We are getting f of x only. F of 2a minus x is equal to f of x. When f of 2a minus x is equal to f of x, what do we do? 2 times of 0 to a f of x dx. That means 2 times of 0 to a, 2a is pi, so a will be pi by 2, 2 times of 0 to a, so this and this will get cancelled. This was our I1. I1 is pi into 0 to pi by 2, sine cube x plus cos square x dx. Same thing, I1 and I2 are both equal. We are getting both equal things. This is same only. I1 is coming equal to pi into 0 to pi into 0 to pi by 2 integrating f of sine cube x plus cos square x. Same thing is coming up. I hope you have understood, right? So you have to see, you have to hit and try. Suppose you want to make the limit as half or double, in that case Queen's rule. If you are not getting anything and you are seeing 0 to a as the limit, directly go with King's rule. Okay, it will lead you somewhere or the other. Okay, now these type of questions, try to see what we can do about it. And this particular question, I would say, this is a common general question. You'll find it everywhere, and this result is also useful sometimes. If you can remember that when ln sin x is integrated from 0 to pi by 2, what is the result? Okay, 0 to pi by 2, what is the result? So my I again is 0 to pi by 2 ln sine x dx. Okay, first thing, when I see 0 to something, first thought in my mind is that, okay, let me apply King's rule. So I'll apply King's rule. Okay, I will become 0 to pi by 2 ln sine of pi by 2 minus x will become cos x. Right, now I'll add these two and I'll get 2i equal to 0 to pi by 2. Okay, ln of sine x plus ln of cos x. So what will I get? Ln of sine x cos x dx. Okay, this is what I'm getting. As soon as I see sine x cos x, I don't know integral of this ln sine x cos x. Definitely I cannot integrate it like that. So what will I do? I'll write it as, I'm going to write it as 2i equal to 0 to pi by 2 sine this. I'll multiply it with 2 and divide by 2. 2 into sine x cos x will become sine 2x. Divide by 2, I'll take it outside. 1 by 2, I'll take it over here. Okay, so this will become ln of sine 2x. Now, this is just simple indefinite integral problem. I'll take 2x is equal to t, right? 2x, I'll take 2x is equal to t. So 2 dx will become equal to dt, right? So this entire thing will become 2i will be equal to 1 by 2 0 to pi by 2. Now 0 to pi by 2, we are putting t. Wait, we are putting t, so limits will change, correct? Now we are substituting, so limits will change. Limit will change according to t. What will this become? 2x is taken as t, so ln sine t, here first ln sine t dx has become dt by 2. Okay, dx has become dt by 2. Where did we get 1 by 2 from? Okay, 1 by 2. Oh, wait. We have made one mistake. Wait, just a minute. This 1 by 2, how are we taking outside? Wait. Just a minute. This 1 by 2 is not outside. This will be over here only. Over here only. We cannot. This is with ln, right? We have multiplied sine 2x like this. We have multiplied this part with 2 and divided by 2. So it is ln sine 2x by 2. Okay, first of all. So now that was a mistake. Okay, 0 to pi by 2 ln sine 2x we are taking as t. So it will become ln sine t dt by 2. So this we can take dt by 2. It will become dx will become dt by 2 minus ln 2 minus ln 2. This will become ln sine 2x minus ln 2. So ln 2 will become pi by 2 into ln 2. When we'll put the limits, it will become pi by 2 into ln 2. Okay, when we'll put the limits, it will become pi by 2 into ln 2. Now 2i is equal to, okay, over here. Now see, now what we can do. See, this part we are getting already. Pi by 2 into ln 2. This part we are getting already. This should be eliminated. Right? This part we are getting already. This we don't want. We want that ln sine x dx should be equal to this. That means main integrand which was there, this I should be only equal to this. That means this is something which we don't want. This is something that we don't want. How can we get rid of it? How can we get rid of it? Over here, simply if we apply Queen's rule. If we apply Queen's rule over here, what we'll get? We'll get 2 into 0 to pi by 2. Right? Because see, put ln of sine pi minus, like ln of 2a minus x. What will be 2a minus x? 2a means pi. So ln of sine pi minus x again will be pi minus t again will be sin t only. Same function we are getting. F of 2a minus x, f of pi minus x is f of x only. So that means when we'll apply Queen's rule, it will become 2 into, this thing will become 2 into ln of sin t, 0 to pi by 2. Correct? Wait. This limit is wrong over here. We had to change the limits, right? When x is 0, t will be when x is pi by 2, t will be pi. So here pi will come. Right? X is 0, t is 0, x is pi by 2, t will be equal to pi. That means pi will come over here. That's why pi by 2 over here. Okay. So now I think we have enclosed, this is all right. So ln sine of t pi by 2, which is again my I only, right? This is again your I. 0 to pi by 2, see, 0 to pi by 2 ln sin x dx and 0 to pi by 2 ln sin t dt will be same. Very first property said that in the same limits, if you are changing with respect to different things but same function, we are differentiating ln sine of t only. Ln sine of t dt and ln sine of x dx from 0 to pi by 2 will give same result. So that means this is nothing but your 2 times of, this is nothing but your, this 2 and this 2 will get cancelled. So 2 times I, 1 by 2 into 2, that means same thing only, this will become I minus pi by 2 ln 2. Now I will come this side and your I will be nothing but equal to minus of pi by 2 ln 2. This was our I. This initially was our main integral. This is what we were integrating and that comes out to be equal to minus of pi by 2 ln 2. Main step was this one. Looking at Queen's rule over here, what will this become? So getting this, here only we understood that we are going to get this, but getting rid of this was only one way possible, that we create I only. Same I if we can create, then we could see that 2i minus I will give us I. That's why we use Queen's rule. And when we are using the hint of using Queen's rule is that here we cannot use King's rule anymore. Here using King's rule will not give us any benefit now. Here only Queen's rule could be helped, because pi was here and we needed pi by 2. Pi was here and we needed pi by 2. Same integrand could be created. We could see that same integral can be created. Limits are supposed to be different. Whenever this is the case, you are supposed to apply Queen's rule. Remember that. Okay. And also remember this as result. This is a result. The value of this from 0 to pi by 2 ln of sin x dx will be equal to minus pi by 2 ln 2. Ln of 2 or ln 2, however you want to say it. Okay. Now some more things about properties, some more observations basically. So these observations are sometimes useful. You can use them sometimes. See how to remember them. If you are increasing b and a by c, if you are increasing these limits a to b with c, increasing a plus c and b plus c if you are doing, then in function just do x minus c. If you are decreasing these limits, or if you are second thing is if you are changing the sign of these limits and interchanging them, right? If you are changing the sign also and interchanging them, a went here and b came over here and we change the signs also, this will be equal to f of minus x. This is quite understandable also, right? This is quite understandable also. When we change, it will become minus, but we changed the signs also over here. So a to b minus a to minus, minus b to minus a, and here you'll have to do f of minus x. These will be equal. Sometimes handily they'll be useful, so remember them, note them down somewhere. Okay, sometimes in question at the final step you will be able to use these. We'll see some questions also related to them. Third property says, if you are dividing b and a by something, then in the function multiply x with that constant. If you are dividing both the limits by some constant, then multiply the same constant inside the function. If you are this one is actually important. This one is not easily, you'll not be able to see. The other ones you can easily derive also. Just put x plus c equal to t and you'll get the same thing. You can easily derive them also, but this one is a bit different, so you should remember it as it is. Sometimes you want to apply the King's rule, but you are not able to apply because limit is from a to b, it is not from 0 to something. Okay, although in a to b also you can apply, this will come from King's rule only. This same thing will come from King's rule only, but sometimes you want the limit to be like this. You want the limit to be like this. In some questions you want the limit to be like this. If you want to change the limit as 0 to 1 and limits are a to b, then this is how you do. B minus a, limit 0 to 1. In function you'll put b minus a x plus a. B minus a into x plus a. In function you'll have to do this. F of x will become f of b minus a into x plus a. Right? This is one important thing. Very rarely it is going to be used. These all properties very rarely. In final steps sometimes you might get to use this, but yeah, you should remember them. You should note them down. Okay, this one especially. Sometimes in some question it is seen that you feel the requirement of making the limit as 0 to 1. Hopefully this type of question will come in the upcoming questions also. But let's see. So proving part, as I said, just put x plus c equal to t. If you want to prove this, just put x plus c equal to t. Right? Your dx will become dt and this will be easily solvable. This same thing will come. The same thing will come. Okay. Change the limits accordingly and same thing will come. These two especially remember. Last one, sometimes rarely, but sometimes it is also used. This one you'll be able to remember also, and you'll be able to deduce this also very easily without any problem. If you want to, okay, this one if you want to prove, you have to write x minus a upon b minus a as t. Although there is no need to prove it, remember it as it is. B minus a, integral from 0 to 1, f of b minus a into x plus a dx. Right? This is how you have to remember it. Just remember it. Proving this and all, there is no need also. And the proof, just for your information, if you want to prove, then you have to put x minus a upon b minus a equal to t, and this will be proved very easily. But remember it as a result. Okay. Now, for example, this question only. We can see that we could apply King's rule or Queen's rule, but here limits are different. The function inside the limit is quite similar, but here limits are very different. Can you see that? Can you see that? Right? minus 4 to minus 5, okay. But if the limits were a bit different, if we want to, in this question only, suppose if we want to make the limit same in this question, although other ways are also there to solve this, but suppose we want to make the limit same for one part, let's do it. So what is a over here? A is minus 4, b is equal to minus 5. Okay, and your f of x. What is your f of x? F of x is, for first part, only for first part I am saying, f of x is e to the power x plus 5 whole square dx, or not dx, why am I writing dx, whole square. Okay, this is your f of x, square over e to the power x also, right? Positive, so not a problem, but still. Now suppose I want to write my, let's say this is my I1. Okay, so now I want to write I1 with limits 0 to 1. So what will I do? B minus a, that means minus 5 minus minus 4, so minus 1, or let me write the formula once again, b minus a into integral from 0 to 1 f of b minus a into x plus a dx. Okay, so what will be my integral? B minus a, that means minus 1, minus 5 minus minus 4, that means minus 1, 0 to 1, minus 1 into x, that means minus x, f of minus x. The what is my f of x? Right? Or let's write like this, f of b minus a into x, that means minus x plus a. Plus a means minus 4. F of x minus 4. This is going to be it. So that will become minus 1 into 0 to 1. Now f of minus x minus 4. That means f of minus x minus 4 plus 5. Instead of x, I'll have to write minus x minus 4. Minus x minus 4 plus 5 will give me e to the power minus x minus 1 whole square. Minus x minus 4, correct. Right, 0 to 1 will be the limits. This is how I'm supposed to do it. Or we can say e to the power 1 minus x whole square. Same thing. Instead of minus x minus 1, we can simply say I1 will be nothing but minus 1 into integral of 0 to 1 e to the power 1 minus x whole square. This is how we can change the limits sometimes. Just for your information, this is something which I'm doing, although you might not, 90% of the chances that you might not get to use this particular thing. Very rarely you'll feel the need of making the limit as 0 to 1, but if you do, use this. Simply use this. Okay. And we'll see I'll show you the solution also. So see, here we are getting minus 1 was there. So minus of 0 to 1 e to the power x minus 1 whole square plus, here when you'll change the limit, 0 to 1, same limit you want to make, same thing will come, but with a positive sign. So minus plus will become 0. That is why we are doing it. So try doing for this one once on your own, and you'll see this is minus of this function, and you'll have positive of the same thing over here added to it. So eventually it will become 0 only. Some periodic function, some things for periodic function. So if you have a periodic function generally trigonometric functions. Okay, generally the trigonometric functions which we see are periodic functions, and in those cases some special properties are used. Okay, so if you are integrating a periodic function, here f of x is a periodic function and you are integrating it from 0 to nt. Now if it is a periodic function, it will move like this, right? 0t, 2t, 3t, 4t, likewise. If it is a periodic function, it is going to move like this, correct? Now what is the integrand? What is the integral? From 0 to nt you are finding. So same thing is going to be added again and again. How many times it is going to be added? It is going to be added n times. So n times same area. This 0 to t f of x dx is this area. So same area you are supposed to add n times because period is nt. This is getting repeated n times. So final answer will be n into integral of 0 to t f of x dx. Now suppose you are integrating from mt to nt. For example, 2t to 3t. 2t to 3t you are integrating. What will it be equal to? It will be equal to 3t minus 2t. That means t. And the area will be same, which is for 0 to t. Right? 0 to t only will be the area. Suppose you are integrating from t to 4t. What will be the area? 4t minus t, 3t. Right? 4t minus t, 3 times this area. 3 times same area. If you are integrating from 4t to t, so 3 times same area, 3 times this area only. Which area? 0 to t f of x dx. 0 to t f of x dx will be this area only. How many times? 3 times. Why? Because you are integrating from t to 4t, or let's say 2t to 4t, so 2 times. So that is why n minus m. Okay, you can relate it very easily. Sometimes in periodic function it is going to be helpful and useful. Now here two more are there. This is the usage of the same property, b plus nt and a plus nt, right? So now what you are doing, you are adding. So here you'll have to subtract, f of x minus nt will come, and that will give you, because it is a periodic function, it will again give you f of x only. Because it is a periodic function, it will again give you same thing, f of x only. You are subtracting this, right? You are subtracting this, b plus nt minus nt, a plus nt minus nt. That is how you are getting b and a. And if you are subtracting here, you'll add x plus nt will be f of x only. If f of x is periodic, then f of x plus nt, the period is t, right, will be equal to f of x only, right? Same thing will come. Same over here. Here m and n are same property over here, similar type of property. So for periodic functions, these type of properties are sometimes useful. You should know them. For example, let's look at this particular question. Now we know sine 2x is periodic. We know sine 2x or mod of sine 2x, this is periodic, and the period over here is pi by 2. Right? Period of sine 2x will be pi by 2. Generally pi, then 2x is there, so period will become pi by 2. And your integrand will be equal to, so 0 to pi you are doing, 0 to pi you are doing, so it will become 2 times of 0 to pi by 2, same. The period is pi by 2, right? So you are doing 0 to pi by 2 and pi by 2 to pi. So same thing will be added 2 times, 0 to pi by 2, sine of 2x dx, and mod is over here. Now in 0 to pi by 2, sine x, sine of mod x, mod sine x will open with positive sign only. Sine is positive between 0 to pi by 2. So we'll just write 2 times of 0 to pi by 2 sine of 2x dx. Which will become equal to 2 times of sin x integral, so minus cos of 2x by 2, cos of 2x by 2, integral 2x is there, right? Divide by 2, don't forget that. And this you'll apply 0 to pi by 2. Here you'll apply 0 to pi by 2. That's it. And you'll get your answer. Okay, 2 will be your answer. 2 only, right? 2 only, correct. Now look at this question. Try to deduce, try to think of the approach. First thing, when you see 1 minus cos 2x, this 1 minus cos 2x, you have to remember the trigonometry over here. 1 minus cos 2x will be giving you 2 sin square x. Correct? As soon as you do this, first starting will be done for the question, right? Starting of the question will definitely be done. So this particular thing, I can write it 2 sin square x by 2 will become sin square x, and square root of sin square x will become mod of sin x, 50 pi by 3. Okay, right? So this will become mod of sin x dx. right? This is the starting step. This you'll have to do on your own. Now 50 pi by 3, 50 pi by 3, if we see 50 by 3 will be 3 ones are 3, 2 0 3, 16 point something, 16 point something it will be. So we'll have to break it first of all. We'll have to break this. We cannot directly apply limit 16 pi by 3 and we cannot check it like that. But and also we know sin x is a periodic function. Whenever we see sin x cos x only inside the integral, definite integral, try to look for periodicity and use periodicity. That's the hint over here. That's the use of the 4 properties. There can be other ways, but this is one thing which directly also you can see that where will it be positive, in which of the intervals it will be positive from 0 to 16 pi. That also you can see. But again, 0 to 16 pi is a big interval. So periodicity will be useful over here. Now 50 by 3, how you can break it? You can write it as 0 to 16 pi, right? Mod of sin x dx plus, now 15 pi by 3, if you want to break it, you can break it 50 pi by 3, you can break it as 16 pi plus 2, 18 pi by 3, right? 16 pi by 3, 48 plus 2 pi by 3, right? 2 pi by 3. You can break it like this. So this one interval, and then here 0 plus 2 pi by 3. Okay, 0 plus 0 to 2 pi by 3 sin of x mod sin x dx. You can break it like this, any problem? Or you can understand it like this, 0 to 16 pi, but again we have written 16, right? So here writing 16 pi to 50 pi by 3 will be better, right? Sin of x mod of sin x dx. Now look at this 50 pi by 3 as 16 pi plus 2 pi by 3, right? Now look at this 50 pi by 3 as 16 pi, this thing is 16 pi plus 2 pi by 3. Now okay, 0 to 16 pi and 16 pi to this we can do, we know already. Now this will become 16 times periodic function, 16 pi, it is, the period is pi, so it is going to repeat again and again. How many times it will repeat? It will repeat for 16 times. So 16 into 0 to pi, same thing, period is pi, so sin x dx. Okay, plus this will become 16 pi, again 16 pi to 16 pi by 3, same thing. Now here it will become 0 to 2 pi by 3 sin of x dx. This you have understood, right? I've broken this. This is 16 pi plus 2 pi by 3. So I can directly write 0 to 2 pi by 3 over here. Right? Direct 0 to 2 pi by 3 I can write over here. Now what? This will become just 16 into minus sin x, so minus cos x, limit from 0 to pi you can apply, and this will also become plus minus cos x, limit from 0 to 2 pi by 3. Just apply the limits and you'll get your answer. So it will become 16 into minus of minus 1 into minus 1, that means 16 into minus 16 into 2. This will become 16 into 2 plus this will become cos of 2 pi by 3. So 180 pi only again, right? So this will become 3 by 2. This will become 32 and this will become 3 by 2. 32 plus 3 by 2. This will be your answer. This will be your answer. 67 by 2. 67 by 2, correct. Now, one more important thing. Important because sometimes, especially in advanced JEE problems, this particular thing is very, very useful. If the question is supposed to come from bounds of integrals or bounds of definite integral, then it is definitely more probable that the question will be of advance, JEE advance. Why? Because this particular art, this is an art only, I'll call it an art. This particular concept is used when you have to cancel out the options. There are many times, many scenarios where you can cancel out the options, and by using the bounds of integral, bounds of definite integral, you can cancel out 3 options and mark the 4th as answer. Many times it will be useful. We'll try to see some problems from advance also. But first let's understand what do we mean by this. Basically, what does it mean? That if there are two functions, there is a yellow function and there is one more, let's say green function. Now, if green function is greater than the yellow function, this bounds of integral, the main concept simply says that if one integral is greater than another integral, okay, if one function is greater than another function, then its integral will also be greater than the integral of the smaller function. Integral of green function will be greater than integral of smaller function, and this is quite obvious also. This area will be greater than this area. This is the main concept behind it. Okay, now some other properties, or we should say the results of bounds of integrals are somewhat like this. First thing which we said already, that suppose between a to b, if your function f of x is greater than g of x, in that case integral of f of x from a to b will be greater than integral of g of x from a to b. Very simple to understand, area under the curve. Okay, why equal to is there? Equal to is there because the function can be constant also. Equal to is there because function can be constant also. Two functions can be constant also. In that case we are putting equal to, or sometimes both functions are equal. In that case, that's why this equal to is also included. Now, second thing, suppose if a function is somewhat like this, its maximum value is m. Maximum value is m and minimum value is m. Right? Let's say for some x which is between a to b. Right? There is some x which is between a to b. Now, if my function whose maximum value is capital M, right? Function is if its maximum value is capital M, then it is always going to be smaller than capital M. And if its minimum value is small m, that means the function will always be greater than small m, right? Then it says in that case integral will also react in the same way. Right? In that case, integral of this between a to b will be greater than integral of this between a to b and will be smaller than integral of this between a to b. This will become m of b minus small m into b minus a. This will become capital M into b minus a. That's what is written over here. If capital M is the maximum value of the function, small m is the minimum value of the function, and function is between a to b, and in this interval only these maximum and minimum values are given, then in that case integral of that function from a to b will be always greater than integral of its minimum value and smaller than integral of this maximum value. And here also equal to is there because in case of constant function, maximum and minimum value will be same. That's why equal to is also included. As simple as that. Okay. Third one says mod of a function. Mod always will be greater than, mod of x will always be greater than x. Right? F of x. Mod of f of x will always be greater than f of x. Correct? Greater than or equal to, yes, greater than or equal to. So mod of integration of f of x between a to b will be greater than integral of f of x, integral of mod of f of x between a to b. So this is also clear to understand. Fourth one is useful, right? F of x, g of x, then it will always be smaller than square root of f square x dx multiplied with square root of g square x dx, right? It will always, mod of integral of f of x dx between a to b will always be smaller than or equal to square root of integral of f square x dx multiplied with square root of integral of g square x dx. That means square root of square of these functions, this will be always smaller. We'll get to use this definitely. Now let's see some questions. Let's say we have to prove it. If we have to prove if this function is smaller than this function, like integral of this function is smaller than integral of this function from 0 to 1, that means what we need to prove, we need to just prove that this part is smaller than this part, nothing else, right? We can easily prove in that case. Now suppose my x, if we say if my x is between 1 and 0, right? Let's just simply prove how this function is smaller than this function. If we can prove that, then this thing is proven. My x is between 0 to 1, correct? My if my x is between 0 to 1, my x square will be less than x. For 0 to 1, 1 by 2 square is less than 1 by 2, correct? So x square will be less than x. I can say that. Acha, minus of x square will be greater than minus of x. If I multiply minus both the sides, minus x square minus x, right? Here we had minus x square and we have minus x over here. So minus of x square will be minus of x, and similarly if I take exponential both the sides, positive only, exponential is positive, so inequality will not change. Exponential of minus x square will be greater than exponential of minus x. One part has come. Now we just have to multiply cos square x both the sides, and cos square x is a positive quantity, so that means my inequality will not change. And that's why I can see cos square e to the power minus x square is greater than cos square x e to the power minus x. That's why integral of this will be greater than integral of this. We can simply say that. Check it out once. In this case, this is different. This is a bit different. Here we are proving it less than a constant. So whenever constant comes, we'll try to create an inverse function, right? Whenever constant will come, we'll try to create an inverse function. For example, we'll try to see that how will we prove it? We have to prove this function lesser than some function, and that function's value should be pi by 2, correct? So first look at this. We'll see that, okay, we know that 1 plus x to the power 6 will definitely always be greater than 1 minus x square. Yes or no? Obviously for x between 0 to 1. X is between 0 to 1. Just check this is correct or not. Right? We'll try to create some function. Two things. In this kind of proving, two things are important. One, you use some function whose integral you know. Right? Because eventually you have to integrate. So that is why 1 minus x square, 1 plus x square, root of 1 minus x square, these we know. Correct? These things we know. And 1 by root of 1 minus x square, we know. And one more thing, in 1 by root of 1 minus x square, the integral will be inverse function, sine inverse. So that's why inverse will give us a constant value. Otherwise, we will not get a constant value. So that should be the approach while proving these kind of questions. Now, if this is the case, then reciprocals will take 1 plus x to the power 6 will be smaller than 1 by 1 minus x square, square root of this. And integral of this we know already. Now, integral of this from 0 to 1, 1 by 1 plus x to the power 6 will be dx will be smaller than 0 to 1, 1 by, so integral 1 by square root of 1 minus x square dx. And this one is the standard integral. This we know, this is nothing but sine inverse of x. And we'll put the value 0 to 1. Sine 1 minus sine 0, that means pi by 2. That means this is always smaller than pi by 2. Two approaches while proving these type of questions, subjective in your board or very less likely to come in board, but directly they could ask the value. In that case, if the values are given as constant, then two things you'll have to remember. First, compare this function which is under the integral, compare this function with something whose integral is known to you. Okay, for example, 1 minus x square integral we know, and we can also say that 1 plus x to the power 6 will always be greater than square root of 1 minus x square. Integral is known, and integral should give you an inverse. Integral should give you an inverse, so that constant can come. Only in how will a constant come inside trigonometry? When it is being inversed, then only. So these two approaches you should be remembering. Now this, for here you'll have to need, for this type of question you'll need to have a good and strong knowledge of the functions or applications of derivatives. Mainly applications of derivatives, not even the functions. First thing you need to know is that your sine x by x is a decreasing function. Apply application of derivatives, differentiate it, and you'll see it is a decreasing function. Similarly, your just like this, tan x by x is your increasing function. When they are increasing, this is decreasing and this is increasing between 0 to pi by 2. Between 0 to pi by 2, sin x by x is a decreasing function and tan x by x is an increasing function. Remember that. Now, you want to compare sin x by x, right? Sin x by x. So, sin x by x. So, your sin x by x, which is a decreasing function in 0 to pi by 2. Sin x by x is a decreasing function in 0 to pi by 2. So, your sin x by x will always be less than 1 and greater than 1 upon pi by 2. Correct? It will always be less than 1 and greater than 1 upon pi by 2. 0 to pi by 2 it is decreasing. This also you can deduce. So simply just integrate on all the sides. This will become sin x by x 0 to pi by 2. Here 2 by pi 0 to pi by 2, and here 1 0 to pi by 2, and you will get your answer. Same thing will be proven. This will become 1 and this will become your pi by 2. That's it. This is how you can prove these type of questions, although very rarely proving will be asked. What type of question can be asked are like this, and here generally you'll have to use, using the bounds, you'll have to use the expansion series. In limits we have studied expansion series of trigonometric functions, right? That will be useful in these type of questions. Now if you want, I'll give you a minute, revise, if you can check somewhere. If you are watching a video also, just try to revise the expansion series which we study in limits for trigonometric functions. Okay, although I'll write, but still, if you want to look at that part, so that you don't get confused. For example, let me write. For example, sin x is expanded like this: x minus x cube by 3 plus x to the power 5 by 5 factorial over here, plus minus x to the power 7 by 7 factorial, and it will keep going on like this. Sin x is expanded like this. And similarly, cos x. Do we have cos x over here? Okay, I'll write. Cos x is 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial, and it keeps going on like this. So why are we using expansion series? That I'll tell you. During in the question. Let's look at the question again. Which of the following inequalities are true? X cos x, x sin x, x square cos x, x square sin x. This thing is given over here, and without expansion series, how will you compare? What will you compare with? Basically, what will you compare with? Try to understand the problem. Are you able to see why am I saying that we have to use expansion series over here? See, when I'm saying this, for x between 0 to 1, for x between 0 to 1, can I say that my sin x will be greater than, between 0 to 1, this is positive between 0 to 1, can you check that? Between 0 to 1, this will come out to be positive, this will come out to be positive, and then it will keep adding positive terms. It will keep adding positive terms for any value between 0 to 1 for x. If x is between 0 to 1, this will be positive, and positive will be getting added to positives and positives. So can I say sin x will always be greater than x minus x cube by 3 factorial for sure. Similarly, here I can say that cos x between 0 to 1, for x between 0 to 1, cos x will also be greater than 1 minus x square by 2 factorial, right? This part will be positive, next part will be positive, positive is getting added to positives, positives, positives. So definitely x cos x will be always greater than this, sin x will be always greater than this. This concept is being used in this particular question, nothing much. Now you can easily compare. So where did the question go? So now, for example, for part A, if I want to see between 0 to 1, my x cos x will always be greater than 0 to 1 x into 1 minus x square by 2. X into 1 minus x square by 2 factorial, or 2 only. Correct? Will always be greater than this. Can we say that? What will this become? This will become, that means x square by 2 minus x to the power 4 by 8. Correct? X to the power x square by 2. Correct only, no? Integrand. X will become x square by 2, and this will become x cube by 2. X cube by x cube by x to the power 4 by 8 only. Yeah, x to the power 4 by 8, and this will apply the limit 0 to 1. So what will this become? 1 by 2 minus 1 by 8, that means 7 by 8. That means this particular thing, 0 to 1 x cos x, is nothing but always greater than 7 by 8. Greater than only, why when we are including equal to, greater than 7 by 8. If it is greater than 7 by 8, then definitely it is greater than 3 by 8. So this is correct. This is definitely correct. Similarly, if we look for x sin x, so my 0 to 1 x sin x will always be greater than equal to 0 to 1 x into x minus x cube by 3 factorial, right? Which is nothing but x square. This will become x square by 2 minus x to the power 4 by 4, 4, 3 to 6, 24. Wait, x to the power, hey, we are doing something wrong, kya? Nahi. This will become x square by 2, so x into x, x cube by 2, correct. This will become x to the power 4 by 6 into 4, x to the power 4 by 24, x to the power 5 by 24. This will become x to the power 5 by 24. And you can check the value from 0 to 1. So 1 by 2 minus 1 by 24. This will become 1 by 2 minus 1 by 24. Will be definitely greater than x square sin x. No, 3 by 10 won't come. 3 by 10 will not come, I think. So this is how you'll check, and you're getting first, third and fourth option as correct answer. The method to check is this only. Okay, the method to check, just put these values and check whether second one is correct or not. For x sin x, I don't think it is correct. I think first, third and fourth only would be correct. Let's check the answer. First, okay, second is also correct. Third is not correct. Third is not correct. Second is also correct. 1 by 2 minus 1 by 24, 12 minus 1, 3 by 10. It is going to be greater than 3 by 10. First, second and fourth. So x square cos x, we already, you can check for x square cos x also. Similarly, same method. You can check all the 4 options, right? And you'll get first, second and fourth as correct. But the method is expansion series. Here the method was to use expansion series. Bounds separately did not come over here. Now comes equations in definite integral. What do we have the role for? Although equations in definite integral is critical because of differentiation involved. You'll have to use Leibniz rule. Only similar approach, same approach is throughout the questions of equations which are used in definite integrals. Very few questions we have seen, but yeah, questions are there from this part also, and there is a constant approach which you have to apply every time. There is no change in the approach. Variety is also same. Let's look at this question. Let f be a continuous function satisfying this. There will be an equation given where integral will be involved. That is the meaning of equations in definite integrals. Equation will be given, and in that equation one integral will be involved. That is the role over here, and the approach is also same. What you have to do? You have to differentiate on both the sides. Just differentiate on both the sides. Whenever you see an equation where differential is involved, where integral is involved, same approach you have to apply. Just differentiate on both the sides. So here when we'll differentiate, on both the sides, we know the Leibniz rule. So that is going to be used. This will become f of t. Just revise Leibniz rule also while differentiating an integral function. Okay, that you'll be having to use, which we have studied in indefinite also. I think in differentiation also. If we have not, then revise it. Otherwise, from your books and from the other sources, or you can see a lot of videos on Leibniz rule also, or Leibniz formula also. Leibniz formula, Leibniz rule, whatever you will search, you will get it. This will become f of t square. You'll just put, instead of x, you'll put t square, the upper limit, f of t square plus t to the power 4 into differential of the upper limit, that is 2t, minus putting 0, this one 0, lower limit, that will give you 0 only, f of 0 plus 0. So it will going to give you 0 only. Minus 0 will give you, this side when you will differentiate, 3 into t square into 4 by 3. So 4t square. Right, you will get 4t square. So f of t square will become equal to, 2t will go here, 2 and 4 will get, this t and this 2 will get cancelled, 2t square, and 1t also get cancelled, 2t minus t to the power 4. This will become 2t minus t to the power 4. Right, what are you supposed to find? You are supposed to find f of pi square by 4. You have f of t square. You want to find f of pi square by 4. F of t square in terms of t you have. Now just put t equal to pi by 2. Put t equal to pi by 2 and your question will be solved. What is t? T square you have to find. So pi by 2. F of pi square by 4. T square means f of pi square by 4. T is pi by 2. Now here, this will become 2 into pi by 2 minus pi by 2 to the power 4. This is how you'll get the value, one of these. Okay. So common approach, wherever you see equations which are involving integrals, just differentiate on both the sides. For differentiating on both the sides, just one thing you'll have to revise, which is Leibniz formula, and you'll be able to do this very easily, right? How to differentiate an integral, for that Leibniz formula is used. One more category we can see over here. This was correct, right? Okay. One more category we can see over here. This is such that, just don't get confused. Now over here, differentiating will not be as easy as it was in the last question. Correct? It won't be as easy as it was in the last question. But yeah, approach is same only. There is no other go. You'll have to start with differentiation. Whenever you see equation involving integral, that means you have to use find f of x. We have to find f of x and not identically 0. Okay. The approach will be same only, differentiate on both the sides. So when we'll differentiate, this will become this side 2f of x, 2 into f of x into f dash x, chain rule. Right? Right side Leibniz formula, it will become f of x sine of x divided by 2 plus cos of x. F of x and f of x are getting cancelled directly. So we have 2 f dash x, which is equal to sine x upon 2 plus cos x. Okay, till here same approach, no problem. Differentiation you'll have to handle. Otherwise the approach is very similar and simple questions will come from this. If you have practiced 10-15 questions also of equations of definite integrals, no, then this topic is not going to bother you. Okay, basic things you should know, differentials and basic Leibniz formula you need to know. So now, but yeah, here how will we find f of x now? We need f of x. We have f dash x. So f of x, basically what was f of x? F of x is a function, for example, we can say dy by dx. F dash x will be dy by dx, in which y will be f of x. F dash x means, what does f dash x means? Dy by dx, where y is the function. D of f of x by dx is f dash x. F dash x is what? D of f of x by dx. This is f dash x. Or we can say dy by dx. So instead of this, we can also write 2 times of dy by dx, which is equal to sin x upon 2 plus cos x. Sometimes this type of problem might come, right? That they are asking you about the function. In that case, this particular step will be very helpful. Now dy, take x that side. What you'll have? You'll have 2 dy, which will be equal to sin x upon 2 plus cos x dx. And now you'll have to integrate on both the sides. That's how you'll get y. Y only is f of x. Y only is f of x. Now, but here it's not, we cannot use definite integral. We are using indefinite integral. So constant will come. So approach will change. Now the approach will change. This will become 2y equal to, this side integral will become, things correct only, not a problem. This will become ln of 2 plus cos x. Correct? Ln of 2 plus cos x. By cos x you will put as t. That's how you are going to do, because its integral, its differential is sitting over here. So cos x you will put as t. This thing will come finally, plus c. Plus c. Now you have to find c. How will you find c? You don't have any value. But one value can be created. What is going to be f of 0? What will be f square 0? F square 0 is given. It's not identically 0, but f square 0 is given to you. F square 0 will be what? 0 to 0, 0 to 0, f of f of t into sine of t by 2 plus cos of t dt. 0 to 0, that means 0 only. This thing is nothing but 0. 0 to 0 will be 0 only. This entire thing, limits are 0 to 0. So whatever comes minus this thing, same, 0 to 0, right? Limits are 0 to 0. Whatever is the integrand, minus of the same integrand, when you'll put the value, when you'll put the limits, final answer will come out to be 0. So basically your function is 0 at x is equal to 0. So here you can do 2 into 0 will give you minus of ln of 2 plus 1 plus c. Cos of 0 is 1. So your c is nothing but 2 minus, sorry, this is 0. So your c will come out to be 0 plus ln 3. So ln of 3. This will be your constant. And then now you can use. So your y, you just divide it, put the value of constant and you have it. Y you can find. Now you have the y. Let's see how they have done. So finally, this is what we are getting, right? Ln of 3 divided by 2 plus cos x. 1 by 2 will be divided. This is what we are getting. Ln of 3, which is the value of c, right? Divided by, this is minus, so divide. Right? Minus, so 2 plus cos x will come in division and 1 by 2 because of this 2. This 2 will go down. Okay. So this is the second category. Only two, basically only two of the categories you'll be seeing in this, nothing more. Okay. Now, next thing, reduction formulae, but reduction formulae, questions based on reduction formulas used to come in JEE. Nowadays, there is very less probability, very minimalistic probability. That's why this is not taught nowadays. But I'll tell you what is reduction formulae. Whenever you have m, n, p and q inside the integral and you are integrating with respect to x, but there is one more variable inside. So in that case, you have to use reduction formula sometimes. I'll show you, I'll give you an example also. For example, let me write. Suppose something like this will be given. In will be given to you and your in will be equal to, let's say some sine, sine of, sine to the power nx dx. Something like this will be given to you. And the interval will be given to you 0 to pi by 2 or something. Now here this means that I1 means sine of 1 to the power x dx, I2 means sine of 2 to the power x dx, and they'll ask you to find something. Suppose they'll ask you what is I proved, or they'll ask you to, let's say we have to prove that our in is equal to n minus 1 upon n multiplied with in minus 2. In these cases, simply you just have to integrate simply and try. While in the approach to solve these type of question where some another variable is involved is only one approach, that try to use by parts. For example, they are asking you to prove this, that I of n minus 2 they want you to create. So now this here you will have to apply by parts, because you cannot get rid of, you'll have to apply by parts and try to get the same integral in that by parts while applying by parts. That's the common approach. Although this is not going to be used, this is not going to come. Yes, notes I'll upload. This is not, the questions based on this have stopped coming in JEE nowadays, but still if something like this comes, just remember, apply by parts and create the same integral. Right? How will you apply by parts? For example, over here, don't apply by parts by multiplying with 1. That won't give you any benefit. Apply like this: sine x to the power n multiplied with sine x to the power n minus 1 multiplied with sine x. Same thing, write it like this: sine x to the power n minus 1 multiplied with sine x. For example, over here only, I'll show you. So when you'll apply this, your in will become 0 to pi by 2. This will become sine of n minus 1 x multiplied with sine of x dx. Here you can apply by parts. This will become sine, first function, that means sine of n minus 1 into minus cos x, integral of second, minus integral of this between this between 0 to pi by 2. Here I have directly integrated, no? So this, I'll apply the limit 0 to pi by 2. Here also pi by 2 was there, and then 0 to pi by 2. Differential of first, that means n minus 1 into sine of n minus 2 into x multiplied with cos of x. Chain rule, right? Integral of this also we'll have to do. So into cos x into integral of second. So cos x will become cos square x. Right? By parts you'll have to apply. When you'll apply by parts, you'll see that this in over here, this at pi by 2, this will become 0. Right? At 0, this will be at 0, this one is becoming 0. At pi by 2, this one is becoming 0. So this is 0 minus, what is this becoming? This is 0 to pi by 2 sine of n minus 2, or n minus 1 we can take common. Wait just a minute. This n minus 1 we can take common. N minus 1, 0 to pi by 2 sine of n minus 2 x minus sine of n x. Right? This cos square x I'm just writing as 1 minus sine square x, and that's why like this. Right? This cos square x I just wrote as 1 minus sine square x. So sine x to the power n minus 2 into 1 will be sine x to the power n minus 2 minus sine x to the power n minus 2 into sine square x will give us sine x to the power n, right, dx. Right? So what are we getting? Basically in will become equal to n minus 1 into what is this? This is in minus 2, correct? I1 will be sine 1x, in is sine nx, in minus 2 will be sine of n minus 2x. So this is nothing but in will become n minus 1 into in minus 2. Here we'll have in minus 2, I can write in minus 2 over here, minus n minus 1 into in. This is in only. This is in only. Minus n minus 1 into in. N minus 1 into in minus 2 into n minus 1 into minus n minus 1 into in. So I think we have proven, I think this only was question, right? N minus 1 divided by n into n minus 2. N minus 1 will come common. Something like this. If not this, then this. But this is what you are supposed to do. Apply by parts. Whenever you are seeing another variable inside your integral apart from x, right? Not substituted variable, something like this, a, m, n, p or q, then that means the question wants you to apply by parts in that. By parts, while you are applying, don't apply by multiplying it with 1. Try to create the same function, break the function, break the main function, and that is the common approach to solve any question based on reduction formula. Okay, and when you'll apply by parts, you'll see that you are actually creating the same integral inside. That's the common approach. No need to worry about these type of questions. Now the very last thing, which is Walli's formula. Walli's formula it is not something which is taught separately or some different or some complex kind of concept, but it helps, this particular formula helps in a special kind of problem. Special kind of problem means something when we have sine to the power mx multiplied with cos to the power nx. Basically this. Whenever you see something like this, that means the question wants you to, is the voice okay? I think voice problem. Okay, if you see something like this, that means question wants you to use Walli's formula. Walli's formula, some mathematician must be there who gave a formula which is for specific kind of problem, and especially the interval of the integration should be 0 to pi by 2, and inside the integral you have sine to the power some power and multiplied with cos to the some other power or same power, doesn't matter. Okay. What are you supposed to do? This m and n can be any whole number, it can be 0 also. M and n can be any whole number, it can be even 0, not a problem. Okay, these m and n can be any whole number, but should be whole numbers, then only Walli's formula will work. What you are supposed to do, start from m, decrease, start from m minus 1, keep decreasing 2's, m minus 1, m minus 3, m minus 5, and you keep going on till if you have even numbers you will end at 1, if you have odd numbers you will end at 2. So either you will end at 1 or 2. Same thing you do with n, start with n minus 1 and keep decreasing, n minus 3, you will end at 1 or 2. This is the numerator. For denominator, start with m plus n and then keep decreasing by 2, m plus n minus 2, right, m plus n minus 4, and final 1 or 2 you will end at. Either you will end at 1 or you will end at 2. And this entire thing is multiplied with a constant p. This entire thing is multiplied with a constant p. Now, if m and n both are odd, only in that case the value, if m and n both are even, both are 0, both are 2, 1 is 2, 1 is 4. If both are even, in that case the value of this constant will be equal to pi by 2. Otherwise, in every case, this value will be equal to 1. 1 is odd, 1 is even, this will be 1. Okay. Both are odd, this will be 1. If both are even, and in this case 0 is even, in this case 0 is considered as even. 0 will be considered as even. Okay. Zero will be considered as even. So this is Walli's formula. How to apply, we'll see in questions. Okay, you can see over here also. First of all, pay attention at the interval. Interval has to be from 0 to pi by 2. Sin x and cos x should have powers, right? Both should be in product. Then how will you apply? You'll start with m minus 1. Then keep decreasing by 2's, m minus 1, m minus 3, m minus 5. Either you'll end at 2 or 1. You don't need to worry. You won't have big powers. So no need to worry about that. N also same thing, n minus 1, n minus 3. Either you'll end at 2 or 1. Denominator, start with m plus n. Then keep decreasing by 2 2's. You have to decrease by 2's in both the cases. Numerator you have to start with m minus 1 and n minus 1. And denominator you have to start with m plus n. Correct? This p is multiplied and the value of this p is pi by 2 if m and n both are even. It is equal to 1 in any other case. If both are even, then only it is pi by 2, and 0 is even in this case. Just remember that. 0 if you are getting both powers are 0, then 0 will be considered as even only. 0 is taken as even. In case m or n is 0 or 1, we simply write 1. Suppose if cos, there is no cos, that means power of cos is 0. Then we'll simply write 1 in the part of n minus 1, n minus 3 and all. Okay, I'll show you with some help of some questions. For example, this is the case. Powers, sine to the power 6, cos to the power 4. Right? Try applying once on your own, whatever you have understood. Sine to the power 6, cos to the power 4. Very simple to apply. Start with 6 minus 1. That means 5. Decrease 2, so 3, then 1. Right? We ended at 1. This is m, this is n. Start with 4 minus 1. That means 3. Keep decreasing ones, so we'll have 1. 3 minus 2, 1. 5 minus 2, 3. 3 minus 2, 1. 4 minus 1, 3. 3 minus 2, 1. 6 minus 1, 5. We started and like this. Denominator, start with m plus n. That means 10. 6 plus 4, 10. Keep decreasing 2's. So 10 into 8 into 6 into 4 into 2. Correct? Multiply with p. What will be p in this case? Both m and n are even. So p will be pi by 2. This will be your answer. That's it. Direct answer you will get applying Walli's formula. And hint is quite clear. So this is what we are getting, 3 pi by 512. Okay. Hint is very clear. 0 to pi by 2 should be the interval, and you should have powers on cos and sine being multiplied. Here there is no sine. So sine's power is 0. 0 is considered even. Okay. We'll start with 8. Right. We'll start with 8 minus 1. That means 7. 7. Keep decreasing 2's. 7 into 5 into 3 into 2. Into 1. Into 1. Cos has 0. So shall we do minus 1? No. No minus 1. If the power is 0 for sine or cos, any of them, then just put 1 instead of putting anything else. There is no n, so we'll just put n. We'll just put 1. Divided by m plus n, that means 8. We'll start from 8, decrease 2's. That's it. Both powers are even. 0 is considered as even. So that's why we'll multiply with pi by 2. That's it. This is how we are going to approach these type of problems. Now, one more I think is there. This is 7531. Correct, right? 7531, 8642. Pi by 2, 35, whatever. In this case, powers are odd. Both powers are odd. Okay, both the powers are odd. Simple thing, we'll start from 5 minus 1, that means 4 into 2 into 1. Start from 3 minus 1, that means 2 into 1. Right? Divided by 5 plus 3, 8. So 8 into 6 into 4 into 2. What will multiply with? Both are not even. If they are both not even, then we'll multiply with 1. That's it. That will be our answer. Simple trick. Basically, Walli's formula is a trick. Okay. Walli's formula is nothing but a trick. That's it. Alright then, so this is all. One more part is there, summation using definite integral. But that, if you need, put it in the comments. If you need summation series also using definite integrals, then put it in the comments. We'll take a separate session for summation of series using definite integrals. Or if you don't need, then don't put. Or we'll take it in some PYQs when we'll be doing PYQs related to this question. If you want it right now strongly, then put it in the comments. Okay. There is one more part which is there in definite integrals, which is summation of series using definite integrals, which I did not include because I thought that will take too long and the lecture will become unnecessarily longer. And sometimes in some of the courses it's not even introduced. Very few questions are seen from summation of series in IIT's exams. So that's it. That's all from my side. I think there is nothing more. That's all. Okay. All right then. So see you all in the next class. JEE Advanced. Bit of right now, please concentrate on mains. For JEE Advanced, I'll tell you, whatever you have not studied while studying for the syllabus of mains, start studying that. See, if you are very confident about mains, if you are very confident about clearing mains in the first attempt only, then prepare for advance. Otherwise, in the race of advance, sometimes people lose mains. I've seen a lot of students doing that. First concentration should be on mains. First attempt. Try to clear your mains in first attempt. Then you'll have sufficient amount of time for advance. Now for advance, solve tricky questions. Solve advanced PYQs only. Try to cover the deleted part. Many part. For example, summation only we are talking about right now. Summation is for advanced, not for mains. So whatever part you have not studied for mains, cover everything now. There are you can find syllabus of advanced separately on many websites. Check which parts are missing. Those parts practice you do. Try to do the tricks. Try to solve the question faster. Try to do the tricky questions, advanced PYQs, and if you are referring books like Cengage and all also, then there will be a separate exercise for advanced. Solve more and more tricky questions. Okay, not lengthy questions. I'm talking lengthy questions are not tricky questions. Okay, tricky questions, advanced level questions. Solve more PYQs from advanced only, right? Solve from 2002 to 2024. All the PYQs of advanced from 2002 to 2024 for each and every chapter. One more tip I can give you: try to study with blocks. For example, you are studying integration, then do indefinite and definite together. You are doing probability, don't do only probability, do PNC and probability together. Okay, likewise, if you are doing differentials, then do differentials, applications of derivatives, both of them, and differential equations together, matrices and determinants together. Solve advanced problems. Don't study separate topics. Okay, all the best, have fun. Thank you, thanks a lot. Don't forget to attend the 10th event, and also don't forget that one amazing thing is going to come up on this channel for 2026 aspirants. So if you have not subscribed the channel, please subscribe it. Also ask others to subscribe it. Like the video if you can, that'll be good for us. Thank you. Thanks a lot.